Namaskar, good morning, good day, Assalamu alaikum warahmatullahi. This is Engineer Singh speaking from Bharat, India. For information, all those who are not in India, we are studying Bharat is original name in our language, India is an English language. These are two names we have, just for information is. So don't think what I'm saying, Bharat is original name of our country. India is its English name. There is no other name, and that's why I'm just trying to clarify that. Well, my friends, this is 25th July 2020. Another day of life and another day of this talk about engineering management, real life management, and professional management that we are all related to and concerned, because without management, without organization, without thinking, nothing moves. And this is fellow, this is Institution of Engineers, India logo, statutory body according to Charter, Royal Charter 1935, of which I am a fellow. I was associate member in 1981, and then 86 I got membership, and then 2-3 years back I got fellow because I didn't apply till then. This is Chartered Engineer in India certification according to mandate given under Charter, according to provisions included within Charter, and the title of Professional Engineer, International Professional Engineer, that is according to international agreement. International Professional Engineers Agreement, IPA, is a body having within this many countries, that is called International Management, International Arrangement of Certification of Engineers, and Institution of Engineers India is a member of that, and we are now because I have been talking of management. I'm talking of this management, FIDIC, general, concrete, COVID, etc. I am not talking of COVID today because I forgot much news except that because COVID is rising but its news are falling. You know what's happening actually. COVID is rising but its news are falling. It's happening, and this is now, let's say, I'm talking of starting with management, quality engineering, and then converting soil, and now video here just to show my input for this for your clarification, because this is one more file I try to show you, because I don't have projector here, and I like to show you so that this is file which I put in my, so this is same as usual, engineering management system, changes, organization, challenges, human thinking only result, and general concrete specifications, total systems, quality, structured and soil engineering, reports, and FIDIC. Generally, I have been working on these days because I think these are very dominating subjects forever. Very dominating subjects in real life, all over the world. They dominating in a sense because construction is vast along the world, economically, not now, but in general, I can say. If we consider budget of nations, because the budgets of the whole world, including government private sector, 70-80% money goes to what we are talking of, world of construction. World of construction, great world, but is it great really? That's my point. That's my point here. This video is a long talk, hour-wise. Previously, I used to make videos of limited duration, but when I realized that limited duration is not efficient one to contain messages that are required to be transmitted to public interest for public, I realized because this is something concrete, something progressive, something essential for public know about this. So I gradually extended. I am happy myself that irrespective of the fact that people are not having any interest in this, yet work doesn't relate to whether someone got interest in this or one doesn't have interest in that. Work is not related to that. Work is related to facts that whatever is to be done is to be done. And I don't expect that people will come like mad rush. No, they won't come. No, this is a thinking subject. What I'm talking is related to thinking, not something else. Thinking everywhere. Thinking, again I say, this word is very simple, very small. Think, T-H-I-N-K. But though it says thin itself is there, K is there, T-H-I-N-K. Just remove K, then it's very thin, very thin. There are two ways of thinking. One is, wide, is having wide brain, is a broad brain. That's one part. But we say thin, very thin, thinner, thinnest to an extent. Thinnest to an extent, you can say even COVID-19 particle is very thin. I just refer to you, I'm not talking of COVID-19, just I'm referring to you. COVID-19, corona particles, very thin, and microns. Not in electrons, in microns, and maybe not in microns, in nanos possibly. Nanos. So maybe not, maybe 10 to the power minus 20 or 10 to the power minus 25, I can't say. It's so, I think, so small particle. You see, great designer, that's superpower. Great designer that can do wonders, and it's one of that. That's wonder here, wonder. Even today, world does not know what actually the structure of mind is and how mind operates and how soul power relates to body power, because medical science or scientists don't realize soul power, but soul is existing, it exists, that's also a fact. So soul is powerful or soul is not powerful, it depends upon an individual. And people say, see, person is spirited and person is not spirited. Two ways. Person is literally spirited, means is ignited, energized. When you say, I am very energetic today, what does it mean? If somebody says, I am very energetic, you say, oh, you are very young man, oh, you are old guy, you are too energetic. This means energetic has got some meaning. Energy, what is that? That's strength of your inner power. It's not body power, it's inner power. Inner means you have to see from within. Why does it exist? It is there, but we do not know, we do not see that. Same thing, everything is there. Every imagination exists in world. That's why we imagine. If I imagine something, so I got picture in mind, we generally say, I got picture in mind, or I got something in mind. But that something is a picture. That picture is mind. I say in mind or in imagination, but that is exactly available somewhere in this universe. That's why it's coming to me, but it's not seen. I can't understand my physical equipment, and this equipment is a body. Eyes is physical equipment, biological equipment. I can't see through it, but there's another eye. I uses a mind eye. A mind can see that. He sees through imagination. Actually, he's watching that, and we say it is an imagination. Same thing we talk in engineering. In engineering, our basics engineering is civil engineering. Second basic is mechanical, then electrical, and further basic engineering are other. But these are top priority basic engineering, and civil engineering is based on imagination. You will say, how is talking of like this? No, I'm talking like this because don't look at civil engineering from building point of view or from structure point of view, which are available or which are under construction or which you say every day something is available. No, that's a physical being of that entity. I'm sorry. That's only a physical being of that entity. A real being is something else. At this point, we have to be clear, very clear about that point. You have to be very clear about physical being, because we are using materials or resources to convert that imagination into this. There is an imagination in structure itself. There is imagination. Common people who do not deal with engineering, who do not have information about how engineering works, for them it may be building, it may be column only, but how these work, how structure of a building operates. We say project is over, but building is operating to some extent. That operation is like plant operates, like factory of something else, but those are seen in factory. You can process goes on in plant or in factory or whatever you see, something is ongoing. And structure is just a structure. It's standing at one place and it's there forever. Just see this building is standing there for 25 years. Okay, 25 years, I agree with that. But this is not standing alone. It has been functioning. It has been working. It has been servicing. It has been serving. Where is that service? Question comes in. That point, engineers understand, professionals understand, but public do not. Public do not. That's what engineering is for people of world, not for engineers. Remember, engineers are medium, engineers are tools, engineers are instruments of using that knowledge of engineering and creating knowledge of engineering and advancing knowledge of engineering and promoting engineering, but not using engineering. User is common world citizen. We are, transmitters of that knowledge. We are converters of that knowledge to physical being. We are transformers of knowledge to physical being. That knowledge we learn, we generate, we innovate, we research and do everything required to refine that, to improve that existing knowledge. That's our job. Physically we don't know that until it's done, but public should know physical entity is working, it works. We learn that. Without that knowledge, I can't become an engineer, I can't create a structure, I can't design structures, I can't understand structures. That's also a fact. Because building has to work, that's why we have to design. Otherwise, there is no meaning of design. We understand structure functions invisibly. We feel it when there is a wind force on this, it vibrates. or there's some earthquake action on this, so it vibrates. That time we understand, oh, it's vibrating, oh, building is vibrating. We come out of homes or buildings. That time we know something is happening to building, but we don't take in positive sense, we take in negative sense. At that time, this function of building to vibrate, to accelerate, that's function of building. But we take it in negative sense. But we forget this is during earthquake or during thunderstorm your building is impacted upon, but it's designed for that. Same thing, building serves 24 hours 7, forever, we don't feel that. That feeling is to be understood. What is that feeling? Engineers know that feeling from beginning of designing the structure. That's why they design. Otherwise there is no need of designing anything. We understand forces work. Forces mean loads, actions work on every structure, and structure responds to them. That's called response of structure to those forces of whatever class of forces. We know that, and we have to let people understand those forces first. Those forces, impose themselves on buildings, on structures, whatsoever kind. And this is stand even road, for example, on which your traffic moves, cars and trucks move, and even railway trains move. All every application, every structure is under work. It works. It responds. That response is called engineering function. That response should be definite, certain, and according to requirement. We is a part of engineering. We have to understand what that option should be and how it can be successful, what medium it is or it can be. We should know that, and that is called engineering part. When those forces are imposed on buildings either directly or indirectly, permanently or actually during some time, persistently or not persistently, accidentally or not accidentally, functionally or not functionally, servicing or not servicing, due to that, those forces are our forces, natural forces. Wind action on building is natural force. Seismic action on building or structure is natural force. Similarly, there is a material force which we provide for that action. This material which we provide to structure to tolerate everything, to respond everything, that is material. Whatever type of material it could be. That material is only material, but that material functions, responds to those forces is come on to that, including its own force. This point we must understand. It's not simply what book says we have to talk about. When they explain to people, the common, and even to youngs, engineering students, it's their right, it's their duty to learn all these elementary points. Until we understand that, we can't do it. It's like body, for example. I'm a body, you're a body, it is a body. Human being or non-human being, everybody is a body. We also tolerate forces. We tolerate, but we don't feel that. That's the point. I feel my body has this much weight. It's in relative condition. I know that weight is due to something, but I don't feel that because I am okay. Because I was born like that. Since beginning, when I was infant, I was light, but I was independent. When I started feeling I'm independent, I could walk and sit myself without external support. That time I am used to that 24 hours, 7 a day. So I don't feel it's because it's my part now, I think. This building my part. Even if my weight increases, I feel yes, it's but I don't. I still walk, I still live, I survive, do everything. I'm too light, I can survive. I'm a building, I'm a structure, simply can say. Why I can't say I'm a structure? I am doing my work, though I'm not like structures where I can't walk. My structure is different. It's a structure designed for walking, for running, for sitting, for standing, for sleeping, for jumping, all that. That is this structure. I am very much flexible in structure. Human body is very much flexible. This point public has to understand and engineers have to understand. I am also a structure. My legs are here, my feet are there, feet are foundations, legs are columns, and my body is a multi-story building, you can say, and this may be some antenna or some other control. And this is my cantilevers, you can say, dynamic cantilevers, or whatever you can call them. And there is a function, there is a sewer line there, water line there, there is a grain silo, there is a food internal fuel arrangement there. If you consider that, these are cameras here, and if you say that way, I am a building, I am a structure. Everybody is a structure. And this structure is still unknown. If you take it in medical sense, if you take it in engineering sense, yes, this is a structure. I can, make it heavier, I can make it stronger. It depends. But this structure is just for me. There's no one else to sit on me and use this structure. Only I am used my structure, you can use your structure. Yes, this structure have inductions, forces, magnetic, electromagnetic forces. That's a different theory. If I consider that, my body is rigid or flexible, that I will understand. If say I am rigid, means say I am always like this statue, we call that statue, right? There is no use. It's no use because it can't do anything on its own. This means my body is flexible, so I can walk, I can talk, I can eat, I can drink. This means function is flexibility and non-function is rigidity. You can say that way. Yeah, I am not saying our structure, but our own. When we understand that, we have to explain to people structure is a living entity, living in a sense mad, or you can say created living. Created living. It's an asset that lives for some duration. That is structure. But we do not know. Yes, we understand it falls or it collapses or we lose this or is destructed. But otherwise, we do not know, people do not know that there is too much action on structures. When I am saying a structure, this includes finishes also for point of discussion, not otherwise. I am talking of total entity, built entity, deliver entity, functional entity. It may be whatever structure, whatever building or this living entity, useful entity, sub-functional entity, or you say operational entity, not under construction entity. This point is very important. Public must understand this. Now, what are those actions which you are talking? Yes, engineers know everything about that. I'm not denying that. I'm not saying that. Engineers very well understand what is that. Now, public has to understand. I talk to many people. It's difficult. They don't only what's there is that's also building finds the building. They say this is a strong building, it's not as strong, this is a good building, not building, and they know we use it. They know that must be known. We use it because they are using it. And not only this building, I mean whatever structure, flyover, bridge, road, railway, track, whatever is there is a structure. Even ship is a structure, aeroplane is a structure, to be very frank. Nothing new is a dynamic structure. It works on ground as well as works in air. It's also structural and it's a structural mechanism. But not like buildings. It's different design. Same thing, ship is different design. It depends on how functional it is. So, but we are not talking of ships here, and we are not talking of aeroplane here. We are talking of ordinary structures. They are extraordinary structures. If you take aeroplane or if you take ship, those are actually dynamic and moving structures. Those are not stationary structures. Stationary is just for survival. Otherwise, functions to fly or function is to sail. Surf on sea. Those functions are different. People know those functions. People know functions of aeroplane. People know functions of ship. People know functions of road. People know functions of flyover. They know those functions. What function of real building is they stay around the clock. They don't know. If I tell them my building is working, it's fighting with forces, they would ask what you're talking about. They simply, what are you talking? How do you fighting? That's what we have to understand. That's what you have to understand. Building fights. Fights means resists. If it doesn't resist, it cannot stay. I suppose I say this building has lost its resistance, lost its power of resistance. You can say strength is lost its strength. Can building stay? You also no, see, this is losing, it will collapse, it's dangerous. Then we call it dangerous. You understand that one. But why it is dangerous points that? This is when it was not dangerous, you're confident with this. This point we will explain to them. Public has to know this. This is where we have to teach them. There is a lack of understanding. There is absence of mechanism to know it. They only know physical aspect of that. They don't understand another aspect, which is factual aspect, which they do not understand. That's very important point. We know forces are there, actions and loads are there. Public also know them. Some people know, not everyone. Those people must understand. That's what I'm talking about. Sometimes you have to explain in a different way. When I talk to someone, my client or I help someone for these designs and art, I have to explain to them what is earthquake force, seismic force, how we use wind, how we use loads on that, but they can't understand that. Just to explain to them, you have to tell them something. Say we have to make this building, we have to design this building like earthquake resistant. Or they may say proof. They may say no, okay. Proof, you may say proof. It doesn't make any difference to design. See, means how it functions. Point is that. So we had to. I explained to them differently. I am making a kind of what you call it, a seesaw, like or a structure that swings. I'm giving you a structure that swings or enjoys, like you're standing on a bridge and a train passes below. Bridge vibrates. I want this building that when you see earthquake action, with this time of earthquake, this building should vibrate. It should vibrate, and when vibration is over, when earthquake is over, I mean to say, when this earthquake vibrates and when earthquake goes, it comes back. That's what I call design of earthquake. It doesn't mean that it takes forces of earthquake and it digests. No, it doesn't take forces of earthquake. It transmits that, it dampens that force. I explain something like that to let them understand. Same way for other forces. You can say live load, or you can say the dead load. They don't understand what dead load is live load. So you have to tell them in their language. You say it's weight of concrete, it's weight of table, it's weight of chair, weight of this fridge. I mean, of permanent weights like this slab, your lintel you are doing, wall you are doing. These are all weights that are forever, that cannot be removed. They are permanent, No one can remove them except when you change your building or demolish it. These are permanent members, permanent loads, permanent, you can say, forces, actions on building. These are called dead. That's why we call them dead. Means this is there forever. Just like dead body cannot be removed from graveyard or from once it is cremated. Same way, this is dead load. You cannot change them. It's there forever. But you have to explain to them the other load also. You are standing on your slab, you are using your building, you are doing something, that kind of, wind is there, wind is not permanent, so that's also not permanent load. Imposed load, they can say applied load, automatically applied, naturally applied load, or you can say your own applied load, imposed load. You are bringing materials, keeping items, this and that. So you have to explain. They try to understand. I talked to some very highly qualified doctors and explained to him, we have so much to do before we do buildings. And she's like that. I show, see, this is code here, so much is given, you have to take this load into your consideration, you have to consider this load, you have to consider that load. It's all to take into that. Yes, my weight I take into that, my everybody's weight we take. They have to understand it's not building on site that is engineering. Engineering is behind that. Building is only small part which you are doing. You are doing construction of structures. One part, not whole part. Means education is missing actually. Education is missing. People's awareness is missing. It's not only here, it's all over the world. For them, building construction on site is engineering, otherwise they don't know anything else. They are not concerned with what you are doing in office, how you are doing that. They think only that construction for 6 months this building took, or 1 month it took, or 1 year it took. That's only engineering, and behind that how much you worked, nobody understands, nobody knows. That's where management talks is means for that purpose I want to educate everybody, and that's why it's public talk, it's not actually engineering talk. It's not for engineers alone, it's for all. So I'm just simplifying that. I'm not using many formulas in this, many technical terms in this, so I'm doing general terms for everybody to understand. And that's only purpose, because I see for people it's nothing. People don't even understand whose job is this. They don't understand. I have seen many people where electrical are working for civil construction. See, fun of situation. You have no knowledge of civil and you are constructing a building. Okay, I agree you are a mason, you are a carpenter, you got some knowledge at least. At least you know something. I'm not saying you are an engineer or expert, but you have constructed some building, you know something of that. Okay, you do not theory behind that, you don't know anything behind that, but you know that this is what it is, how it works. Or at least load will be transferred, not transferred. Those points, at least those technicians may understand, but those technicians may understand, otherwise other people may not. That's point of really I'm serious of. And it's when we explain to them, then they try to understand, and then when they try to understand, then they can understand foundations only. For them, foundation is people used to say, I was too young and talk to them, say, oh, see how much down we go, we can go how much up. Same way. An understanding generated in minds of common people. Whatever depth you can go, much depth means much height. Common sense, people like that. Because it's not their fault. I don't say that. It's not fault of someone, it's fault of society. It's fault of society. It's not only how building works, what material we are using, that's also a question mark. People know, see, this is concrete, linter. There is no meaning of linter, but they call it linter. Same way, they say it is bricks, but they don't understand what's bricks. They don't know what is composition, because nobody tells them. They don't know what is concrete, what's the purpose of concrete. They say yes, it's concrete. Then they don't know the purpose of steel, and for which we are using steel. I have used so much steel in my building, so many tons steel, and how many kilogram per square feet. That means they have their own world. They don't know, but they take responsibility of that, and that is very important point to understand. A person who knows nothing, about structures, nothing about buildings, that person takes responsibility with guarantee, with warranty. I take 50 years warranty, no problem, don't worry, I am here. And warranties are verbal, verbal warranties, without any bond, without anything. And they convince in a way that they knows everything. That's beauty of, spoiling profession. Those people who do not know ABCD of medical science, they are doctors. Those who do not know anything about engineering, material or engineering sciences, they are engineers. They are builders, they are promoters. That's why, quality has gone wrong. That's why. Why I'm concerned because in our country, particularly in our country, India, Bharat, and quality is missing, perfectly missing, I can say. Maybe exceptions are there, 1 or 2%, otherwise whole quality in entirety, not in one item or two items, in entirety does not exist, in entirety. That's say, you should not take it ridiculously, it's factual, and that's why I'm concerned. Yes, it's different that I've experienced overseas, I've experienced those jobs on employment basis, of course, and I learned little from them, from those jobs, and that's my good time, you can say, because something you learn from somewhere, you can say it's good job, good time. And if you don't learn from university, if you don't learn from your field of engineering in job, and you just say, as I'm in job, I'm occupied, I mean, the job, having job is one part, but learning from job, learning on job, and what you are doing, you learn that, you innovate in that's the fact. When the engineering itself is intelligence, it's no question of pride in that, it's a fact that engineering itself is intelligence. It's something, you have to investigate at each point, at each activity you do design activity or you do some activity, you have to think, you have to investigate. Investigate not criminally, investigate intellectually. If I am, say I'm designing on the column or I'm designing beam or I'm designing, if I design slab, that's elemental design, you can simply design that. But design comprehensively. Design is a part of unit. Unit means whole structure, how it functions. That's different design. That's innovative design. That's where you need to think a lot. Think, and then decide. Think in every stage of construction, before construction, you have to think that. And even after the construction, you have to think that. Defects always you find in building structures, like that. So when we say foundation, people understand differently. Foundation takes load, they do not know transfers load. That's the only difference. They know there is a foundation. Without foundation, building can't be strong. They know that much. But they only know foundation. They don't know purpose of that foundation. That's where, again, problem exists. They know, oh man, I have gone 5 feet down, 6 feet down, 2 meters down. What strong foundation I have done? They say you are going that much down, you are strong. Building is strong, foundation is strong. This is where, these are, you can say, gaps. These are gulfs. Gulfs, you have to treat them, you have to join them, to bridge them. That's where, engineering dissemination, engineering knowledge dissemination is essential. Because engineering is meant for public, not for me alone. I am just a tool. I am an engineer, it's not for me. I know that because I have gone through that training. I have gone through experience, or people are experiencing. They understand that. Just like a doctor has to explain to his patients how they have to conduct and why is this purpose of this treatment or operation, they explain them. They explain to all. Same explanation is missing in engineering because engineers have a distance from public. That's where drawback lies. Engineers are not accessible to public, and those who are engineers in their families too, they don't explain, because if you explain, people don't take interest. That's one point. But when you explain, when it is required, they can understand. I don't deny that. I'm not going to tell them sections of this design or form. No, I'm not talking of that. I'm talking fundamentals, basics, why we are doing this. Example, I give something like that, psychological examples, which I face myself. I architectural design I did for some houses for my relatives as well. I say, what instruction comes in, don't use odd number of steps. That's one instruction. They don't care your height or your riser, what should it be, they don't ask, no, don't take odd number of steps, care for vastu. and so many such types of instruction. Don't keep toilet here and there. Don't keep this and that. And Pandit or Vastu expert is more important than a building or design or engineer, because the engineer has no qualification. Vastu has every qualification. People's psychology has been impacted upon. This is impacted upon. That's why I want to explain to them, and they feel because it doesn't believe in this and they should talk like that. I say Vastu is not for you, your house. It's for you. They don't understand it. Actually, it's for human being. They think it's for house. Human is self a house. They don't understand that. I am a house for me. That's it. My house is something else. What is going to be Vastu? But they accept that. They do not want to know anything from you, because you are not Pandit, you are not Brahmin, you are not educated in that field. Do not talk like this. That person is educated, you listen to him, we don't listen to you. When they call those type of persons for inauguration or for what you call land worship, they simply, I was barred from their way. My sisters, don't. What? No, don't. Pandit is coming and that Pandit shall do worship of Earth, Bhumi Pujan. I didn't go. Okay, why should I worry about that? When I saw that after going, when they heard, I was, why this pit is here? For that worship, they excavated one location, and that location was main column, prime column. I asked, what you have done? Why you excavated here? You excavated 5, 6 feet down, 2 meters down. Why? No, this is where worship Pandit said that here we have to worship. This is point. What kind of worship? I was very upset. You have done something, blunder. They don't understand. No, he said, what about it? Okay, you do this, all you want to do. I don't fill it with concrete then. What to do with that? Means those people have brainwashed everything. These corrupt people, they are just, they just mislead whole public. They just mislead religiously. They just abuse sentiments of people. They don't care. Engineering is a religion. They don't understand. We have to learn everything. We have to give them something. Making materials together, raw materials together, natural materials. When I say raw material, natural materials, same thing. We give them something like they cook. They cook vegetable in kitchen. They cook chapatis. We are giving like that. They do not realize that point. They do not realize what you have learned. What's your theory? What's your practical? Forget that. What is this soil? We don't know that. But they say, my building should be not be cracks later on. There should be no leakage, or there should be no seepage. That they know because of experience, not because of learning. There is seepage always in foundations. You see, in basements there is seepage. And you can say buildings, if seepage goes up or down from top to bottom, it happens because of technical reasons, because of problems they did not take into consideration at time of designing and construction of those elements of the building. That's why this happened. They do not understand about soil. They do not understand anything about that. No, this also happens. Soil is like that. But I am explaining all this because I am come to soil. My target is soil. It's technical management. It's not managerial management. It's real management. Management can be amended, but soil action cannot be amended. Once you do, you lay foundation. Once you do it, you found decide something, cannot change it. And even this brick wall can be changed, plaster can be changed, structure cannot be changed, and foundation cannot be changed. That's purpose of what I am preaching to soil which is very little valued. I don't understand reason behind that why it's little valued. Even though it's one room project, you have one room, but foundation still exists there. You have to construct foundation, and you cannot know it's only one room. Why do you do such as here? It's one room or 1,000 room. Every area shall has foundation. Even light poles on reefs, you go and see light poles on road, on streets, all are, you see how foundation they construct. No technology, nothing, they just construct and go in. For them, it's just the light pole, nothing. Why for them? When same light falls, this has happened, that has happened, some person died. That time they complained, and when somebody tells them, you have to take care of this foundation, you have to take care of design, nobody takes care at that time. Means that time we have to take care, we cannot take care, we don't want to take care. But later on we complain. I don't know to whom we complain then. We complain to ourselves or to our foolishness, we do not know. Soil, again I tell you, soil is soil is, you can say, generator of your building. It's not design. It's not design. Soil that carries everything of your building, its impact, and digests it, dissipates it, mitigates it forever. Every moment without fail. There is not a single moment the soil doesn't work for you. Do you understand that? Soil works for you, for your structure, all time, without fail. It's like you're breathing in until your death. You're breathing till your death. Same way, from very first day, when you start excavating your building, soil starts working in. It starts working in when you excavate it, or even in place a peg for setting out, it starts working for you. You excavate it, means you remove it from there, you break its body, you take out earth material, and you excavate completely. So it has started working. You have broken soil. You have disturbed that material, which is silently sitting, enjoying its rest. I don't know for how many years. Now you have broken that. So you have attacked soil, right? I am saying jokingly. You attack actually. When we say on site, to start something, modernized body, don't say don't go and do this. Say attack on this, attack on excavation, attack on this item, attack on that item, because you are going to do that from scratch. Nothing exists there. You are going to attack excavation. So what soil will not do anything. It can't encounter you. It will be submitting you. It will submit, so okay, excavate me. But soil has started its function. Try to understand that. When soil is excavated, you have dismembered soil. From that point, you have broken it. You are doing surgery of that soil. And then you don't care for that. You are not taking your people fall in that. Something happens, you are not even taking safety of that operational, that surgical item, surgery item it is. Well, you have started soil work. Earthwork is soil work. Then you have to beat it, you have to set it, you have to dress it, you have to shore it, and do a lot in that. For people are going in, coming out, going in, coming out, machines are going in, coming out. Who is weeping? Soil is weeping. Because pain goes to soil, you are not feeling that because you do not understand that soil is a material, it's something not very expensive. Leave it as soil, don't worry about this. It's dust. If it's loose, it's dust. If it's not loose, it's soil. Its surface, right? Its formation level, right? We all consider that. Then we do it, dress it, water it, and compact it. So you think soil doesn't feel anything? If there is a soil, it must have some soul in this. Soil and soul, only difference of I. There's a I in that and there's a U here. That's only difference. SOIL and SOUL is no different. So soil corresponds to soul. Because your soul is there, you're building, you're constructing, you're building, or whose building it is. Somebody has to live in that, and don't forget that's where we start. So we start by kicking, by attacking soil, and soil says, do not attack me. Okay, my friend, if you attack me, no problem, I would not attack you. Soil never attacks you. That's another point. Soil does not attack you, but it demands something. That demand is what? That's question mark. Soil says, attack me, no problem. I am happy with that. You are using me, but you first learn everything about me, how I conduct. I am this type, I am from that location, I came from that area. You first learn about me what I am, and if you don't learn about me, you will mistake. Because I can't change my behavior. You can't change my behavior. But you do not know my behavior. You do not know anything about me, but you are going to use me without knowing me. And when you know me, you will be happy, you will not be sad, because I will give you protection of that. If you know me, you treat me, and then I will be happy that, okay, you broke me, you did everything, but you filled with some good material, you filled with some good foundation, and you kept me in place of soil. You put some different material there, so material of soil has been replaced. Now I am saying material of soil, that's another point. Why? Your soil, you're calling material. What does material mean? It's not material. It is material. It is material. It is certain material. More important than every other material, because this material is supporting material. This material is final material. There is no other material after that. It is infinite. It's unlimited. This material. Unfortunately, this type of analysis we don't understand, we are not taught. We are taught only what we think is right. Is structure whatever on soil, from soil level, foundation level to your top of building, all entities in that, all you can say load and actions on that. Soil is tolerating them. Soil tolerates them. You did not produce soil at all. You did not produce soil at all, but you are using that soil. You produce other material. You produce artificial stone, which is concrete. You produce bricks. You produce everything else. You are using them to torture soil, to beat soil, to force soil. What's fault of soil? No fault of soil. You are coming to beat from every aspect of the soil, to beat it to death. And that's that point we have to know, because soil has death sometimes. That yielding point, which I am calling death, is very important. That yielding point you have to understand before your whole building becomes dead. Your whole structure becomes dead. Sometimes you have to talk in a way people do not understand anything. But here I am talking in a way they should understand life and death. You don't forget soil is your life and soil is your death both. Soil helps you when you are dead, and soil is helping you when you are living. This means it is your dead body control, it is your living body control, it's your building control, it's your development control, it's control of life, of everything. It's for animals, it's for everyone, it gets supports. It is so strong, but you do not respect soil. If you have respect, then you should use it properly, you should study it properly, but no, you do not say, "Ah, no, forget this. Why should I test this? I know everything. Say this is very good soil." People say, "Oh, see, this is very good soil." One of my friends used to take me to something. "Oh, this is very good soil, Suresh. How this is very good soil. See, it's so strong, it cannot, I pick it. Yes, this is very strong. Now do one thing. Get me a bucket of water. Take, come on, put on this. It will become dull. It's become now what? Sticky. It's very good soil, right, architect? For contractor, that's very good. For you, it's not very good. Contractor doesn't know anything. It does not understand anything. Builder does not understand anything. Oh, it's very good. My foundation is strong on this. Misconception. Misconception works a lot in engineering. You know, there is a soil called silt, there is a soil called clay, and there is a soil called sand, and there are many more in between or intermix, or you can say not exactly. Some soil is 100% in one range. There is no pure silt, there is no pure clay, there is no pure sand, or from somewhere else. Something is there, something is mixed up. Nothing is pure. Polluted soil, you can say. Every soil is polluted in that way. What is that? We have to understand. What is that? How to understand that? Who will teach them? How shall they understand what they have to see? That's only a point where I put a stop. That stop is very important to unlock. You know, engineering means you have to understand subjects by priority. I think this is a priority. You can make one room or you can make whole town or city, but everything shall rest on soil, don't forget. Flight takes off, goes to 10 km height, but it takes off from where? It takes off from soil and it lands at soil itself. Your road is there, runway is there, but below is what? Road is structure, runway is structure, and below is what? Soil. Soil is very strong word. For engineers and for all others, it's very strong word. Because you have to live on this, you have to use this, and you have to go into this also. Your ashes will be thrown away to the river, and they are settled down as sediments, permanent sediments, or flow somewhere else. Bones will settle there. Ultimately, you have to go to soil, and we say he has gone to Panchatattva. Is one part of Panchatattva. 5 elements, natural elements like soil, like fire, like water, like air, and even. This is one of them. Essential. Air also affects the structure. Water affects the structure. Fire affects the structure. But soil is permanent. Air is not permanent. It may affect, may not affect. Action of air is not permanent. Action of heat is not permanent. It changes. But soil is there forever, which you cannot take out. If you take out, you have to remove your structure. You have to demolish that. That's where my interest lies in. My interest is that I'm trying to explain to everyone, do not undervalue soil. That's my objective of this soil. Always problems are caused by soil, and solutions are also given by soil. I have met many engineers in my life. Many nationalists, not one, not two. I think covering all range of work, and same not only engineers, lower staff, workers, all those who are part of engineering team, construction team. They are experts in doing job. They can do job. But if you talk like this to them, they won't answer because they don't know anything. This means there is something that's missing somewhere. We have to identify that, we have to understand that. That is real knowledge of soil. Real knowledge of soil. I am not giving you real knowledge, I am just trying to strike into you. This is pending. This is pending to learn. Some people mind it, some people don't mind it. But ultimately, you like it or you don't like it. You are forced to use it. You cannot do otherwise. You are forced to use it because this is permanent original material and it will remain permanent original layer also in your foundation. That material shall help you every way, every time, all time to come. That material is soil. If you have a capacity to realize this fact, you shall be a better person later. Unfortunately, 98% people, or you may say 95%, are not aware about facts of soil. I don't want to depend on softwares for purpose to know my soil, because software cannot teach anything. Yes, they are themselves, they are something, they may something. You can read that if you wish. It doesn't make a difference in the harm. But reality lies that it's your job to understand that soil. You cannot blindly say, I got a technical report on soil investigation in this area, and this is a three volumes of this, or 1 volume of this, 2 volumes of this. They should be there, volume should be there. It depends on how much restriction I cover. That knowledge should have. That's why I was trying to discuss with you about soil, and that's because I am talking to you at length. So it's now about 1 hour I'm talking to soil. And it can be talked for very number of hours, because this is different subject. This is, something indispensable, cannot be indispensable. You may not be surprised, this is now, I'm sitting here early morning at 3 o'clock, to say I checked weather report here on AccuWeather. It's 91% relative humidity. I started. 91% relative humidity. This means this is either Doha, Qatar, or it's Dubai. It's not Faridabad in Nepal. But you have to. Means moisture content in air is called humidity. Its measurement is called relative humidity. It's so much percentage of water particles lie in air. Humidity is around your body, and particularly in daytime, when you are in sun, what happens? You feel higher temperature than happens. Reason that sun force, sun rays temperature evaporates your particles of water, and you are impacted upon by that pinching pinching actions on your body and soil, on your body. Relative respect for soil is that you have to treat soil like you treat your humidity, like you treat your temperature, like you treat your, how to live in this air. Soil embeds foundation. Soil covers foundation. Soil protects foundation. Soil does everything to accept every gram of load from imposed on this from whatever members, and then dissipates this, then digests this below that for permanent work. And soil then protects, you say, foundation, at the same time soil attacks also. Soil protects it, soil attacks it. This means soil is protecting also. If you understand that, soil protects it. This, you have to make that type of arrangement. That arrangement is known as soil management, soil organization, or soil you can say mechanism, rock mechanism, whatever you say. Soil engineering, soil treatment. For someone it's only foundation, because we are doing foundation, we have excavated, we have done this and this and that. For them it's physical work. For them it is physical work. But for engineers it's not physical work, it is technological work, it is engineering work. It's the work that helps soil work better than its normal state. You impart soil with some properties, that soil plays our friend forever. You perform better and don't harm our structure. That is, different kind of relation to soil. Soil is for you, for me, for everybody, in that it won't cheat you throughout your life, though you do not care as you should have done. I have seen many examples, many problems here in life regarding buildings, through architects of course, because they problem they face first. People call them, see, my basement has gone up. I mean to say, so ut gaya basement, means they don't know actual term. The basement is heaved up. So say, why? What's the reason? I don't know. You don't know. You are architect because you constructed that building. Yes, I constructed. I don't know why it's gone up. This is what I say. When you face some problem, when you face some difficulty, that building is unable to respond, soil is unable to respond, soil has lifted that building, you are not understand, you don't understand the reason behind that. What do you call it? I call it non-professional activity, or I call it absence of information, I call it overconfidence in people. Overconfidence. Professionals understand all this, but they don't accept that. Because they also do not consider worth valuing it. Actually, to be very frank, same purpose is here, that I am making all these videos so that people should understand what it is. I am doing it without any interest. I have no interest in that. And I am not saying that I am an expert of soil. I am not expert of soil. I am just like student of soil engineering without any classes. I again study when I have chance to learn something. I just learn. But when I learn, I find so many errors in some literature, some catalogs, that writers sometimes they either copy from somewhere or they quote from somewhere. They don't analyze that before. So well, this is their own. I'm not I'm not going to that. When I say I start, we have to understand soil, and soil understanding is really achievement, I can say. You know, I've seen people working a lot, engineers working a lot, and they're calling themselves designers, and I am happy with that. You're a designer. It's good that you're a designer. I don't mind that. That's very good, you know. It's a very good point in your life that you're a designer. You're going to design something new. Every design is new. Every design is innovation. You can say design is not copied one. It's not that somebody gave you, you design yourself, you thought yourself. Design means thinking. That's very important part. So you design something. If you give me one design to 2 or 3 engineers, they will all different separately. So this means there is no uniformity in thinking. You can think one way, other think, or you think both way and design in different ways. So I respect that way. But don't stop at foundation. There's where people stop and they assume something else. That's the problem. All you designed, everything you designed, you consider each and every point, each and every node, each and every modeling you did. But at end, you did not understand what you did. You just designed it for sake of design, and after that, you forgot that. When you reached at bottom, at formation level, you forget everything. That's where problem lies in. What I mean to say, you design everything. You design from top to bottom. Even you consider seismic action. You consider wind action. You consider dead actions, dead loads. You consider live action. You consider persistently, accidentally, or you can say temporarily accidental loads. All that you consider. But when you reach last point, you reach that material which shall help all your loads to survive safe, and your structure remains safe. When you reach at that point, you after that start assuming. You start assuming, and here you are not assuming, here you are claiming on codes, on this and that, calculations. But when you surrender all this, you submit all this report to earth, when you submit your report to earth, your design report to earth, you go astray. I would call it submission to earth, submission to soil, your design, everything, you submit to that and live to that. That's an error, live to that. Assume something, you start assuming, you start doing something which you did not do. You did not force that person to do soil investigation, which should be number 1 activity, or you can say ground zero activity. After that, you have to think for design of foundations, particularly foundations. You can design whole upper stories, no problem, but when you come to track foundation, you must have every field in information, which you never do. Somebody says, oh, it's very expensive, soil investigation is expensive. I don't know what expensive. Your building is cheap. Your building is cheap, you think so? No, it's not cheap, it's expensive as well. So why do you say only soil investigation is expensive? That's the point. Until you value soil, you cannot deliver reliable buildings, remember. You may call yourself whatever job you are doing, but if you do not understand designs, you do not understand how to handle when there is a problem, at that time you are blank mind, blank. Well, keeping on talking like this will take another hour, 2 hours, and no use of that. I was talked yesterday about soil classification. Soil classification. It's just reference book. I'm not saying you buy. There's nothing to do with that. Because I studied this book when I was learning. I was studying. I took some help from this book, not exclusively this one. There's so many other books, but I'm just Because I have this copy now, so I'm referring to other. I would refer from other one also, or I would use codes directly. But codes are not, I think, the total teacher codes are only reference. Sources, resources in engineering, that is the system. So we just, I'm not saying this is perfect, nothing is perfect, but some information is available, and that's the important point. That's where we have to stand with. Now, I talked classification yesterday, classification of soil. Yes, it was here up to, we had gone through in this arrangement of classification of soil or category of soil. Says we have gone through in this soil classification. This is grain size, grain size district classification we did. U.S. Bureau of Soils triangular classification systems we did, and soil classification according to category plasticity chart we did, and public road administration classification system also in PRA system we did, and unified soil classification system we did, and Indian standard classification system we did it. And this, I'm not talking about something that relates to all. Then we studied grain soil classification, in which were gravel, fine gravel, coarse sand, medium sand, fine sand, very fine sand, silt, clay, etc., etc. The classification, there is MIT and ICE classification. Same one in US Bureau of Soil triangular classification. We did that, and also this category soil classification according to category, and then also like this we did in public road administration soil, and then also we did, after that, after this unified soil classification category, and then it's, and this is Indian standard qualification. All we did. So we then had to read this table, and also notations of what is required. And the table which we studied, like to show you one by one, means what we studied actually, just for your refreshing memory. Like you can say that there's a table which gives grain size classification. Grain size classification, that's here. I'll show you maybe say. I can put off like this, I get it better. For example, it's there. This is like fine gravel, and fine gravel. It's here, chart is the classification. Here says gravel, fine gravel, coarse gravel, coarse sand, gravel, fine gravel, coarse sand, medium sand, fine sand, very fine sand, silt and clay. And the size range is given there already. Then this is a further representation used in terms of rows. And then if you go out to other one, that's this classification is US Bureau of Soil triangular classification system. And then there was other one, which is category. Category 6 types of soils indication. Category. After that, let's have the one. Is then public road administration here. Public road administration here or no? Then there is unified soil classification. Then you can say Indian standard classification. And out of that there are tables. That tables are the which probably yesterday tables. Like that other table. And likewise another table. And like that information. And then we are here. Various locations of soil. We also learned structures, soil structure. And then other structures can learn also, structure the structures as well, you know. And then we also this all the structures are like this. Then you have to see humidity is much really 95%, really difficult to say. So we also talked of, I think, Stokes law. Sorry. Sorry, just for finding the page. I am missing that page actually. Just finding that page. Sorry for that. We also talked of this field compaction test here. We talked this field compaction test. We also talked of stability of slopes. Pavement design. What's that? I think it's Wisconsin. Yeah, I guess so. So establishing it was. I thought it size stabilization. Soil stabilization. Yesterday we talked what stabilization about. We talked that, and there's some ways basics of that. We talked of mechanical. We had to talk about many minutes. Basics level review. I talked about soil stabilization is not. It's alternation. It's alteration. Soil stabilization is alteration of property of soil to improve its engineering performance. This means soil is doing engineering performance. It does it. Soil is engineering performance means soil is a bigger engineer. Soil is an engineer, you know. Soil stabilization is only one of many methods available to soil engineer, and this change is adopted only after a comparison with other documents. It's only one of many methods available to soil engineer, and this technique is adopted only after comparison with other techniques. Buildings, dams, roads, transport, etc., all rest upon soil, and many of these structures also enjoy soil in their construction. Obtain a soil at a particular site is most satisfactory for a particular use, or it exists in ideal, but in most of cases it's just possible. So Chairman says that to obtain what it says, rest upon soil, and many of these structures also employ soil in their construction. Now to obtain a soil at particular site which is most satisfactory of a particular use as it exists in ideal, but in most of cases this is not possible. Following are various methods which are adopted to deal with unsatisfactory soils. What are those methods? What are those methods of talking of, which must be used? Direction change, stretching legs. Now, says one method is bypass poor soil, other method is remove poor soil, third method is redesign structure, and fourth is treatment of soil to improve product. Right? We talked just refreshing what we talked yesterday. Too much. Bypass. Bearing piles are used to locate a bridge load through weak soil. To a firm soil, firm strata, highway alignment can be changed to avoid a swamp rather than try to transgress it. Okay, sorry. Remove poor soil. Like peat, sometimes we remove from site and replace with good soil. Redesign structure. All structures, foundations may be redesigned to account for poor bearing capacity of underlying soil. Then treatment of soil to improve properties. This is known as soil stabilization and has been dealt in details in this chapter. And what is that? It is, you can say, increase or decrease strength. What I am taking is that soil stabilization for its purpose is increase or decrease strength or reduce sensitivity of strength to environmental changes, especially moisture changes, to increase or decrease permeability and reduce composability. That's what soil requires. Let me take some water also. So soil stabilization, a very important part of engineering. To increase or decrease strength or reduce sensitivity of strength to environmental changes, especially moisture changes, and to increase or decrease permeability, to reduce compressibility. Soil stabilization has been successfully used for all types of engineering problems. Its most common applications are strengthening of highways and airport pavements. Now, methods. How to stabilize soil? Mechanical, cement, lime, bituminous membranes, electrical, thermal, chemical, and maybe more. Mechanical stabilization. Mechanical stabilization Mechanical stabilization covers two methods of changing soil properties: rearrangement of soil particles, this is one, or addition or removal of some soil particles. Rearrangement of particles can be done either by blending of layers of sterile soil or by removing an undisturbed soil sample. Now, say mechanical stabilization. So, rearrange soil particles or remove or addition or removal of soil particles. A rearrangement of particles can be done either by blending of layers, blending of layers of a stratified soil, or by removing of an undisturbed soil, or by compaction. Rearrangement of particles can be done either by blending of layers of a stratified soil or by removing of so now we go to compaction. You know compaction very well. After all, this compaction, this dryness, the granular stabilization, then that's what's compaction about. Process of compaction soil is oldest. And this is process of compacting soil is oldest and most important matter of soil stabilization. No, compaction is very big size, but we are just defining it. What is that? Process of compacting soil is oldest and most recently okay. If I do not I can finding uncomfortable sitting actually because of this humidity, I see differently. I think my pose was not correct because I'm referring to book also. It's not because of if you are not finding comfort in your sitting or working, it's difficult to work. process of compacting soil is oldest one and most important method of soil stabilization. Most time, compaction alone solves a particular soil problem and is generally most economical of techniques available. In addition to being used alone, economical of compaction, addition being used alone, compaction procedure is an essential part of number of other methods of stabilization. Compaction improves interlocking increases apparent cohesion and reduces pure dimensions. This is it. Due to this, so it says due to this phenomenon, shear strength of soil must vary. So, in addition to being used alone, compaction procedure is an essential part of a number of other methods of stabilization. Compaction improves interlocking, increases apparent cohesion, and reduces pore dimensions. Due to this phenomenon, shear strength of soil mass increases. Shear strength of soil mass increases. This means it's what time? 5:11. If I can go outside and put this off first. Give food to birds and come back. 1 minute please. Maybe they cry otherwise. otherwise they will crow and cry and call me, disturb me. So back to work. You understand compaction? We talked a lot about this actually. It's packing of material, packing of grains from existing state to further densification. It's not simply compaction. Pack them as much as possible. If it's granular soil, it's very nice. It's granular soil. Means it can be better interlocked. As much as interlocking is done, better compaction it is. So means cohesion, or you may say if it's mixed up and 4 dimensions, you reduce volume voids in air voids in mass of soil. You reduce that one, and you increase density of this material as much as it can be, and you can say strength, shear strength you can increase. So there can be increase in shear strength, there can be reduction in volume of voids, there can be repulsion of air from there, and you can improve interlocking of particles of soil if these are angular and granular, not globular. And cohesion, you increase cohesion, and if there is adhesion as well due to nature of soil, it can be done. Compaction, if the natural ground is fine, it's even done in that case. Many reasons are for that. Now come to drainage. Now this was compaction, one reason. Now come to drainage. The strength of soil generally decreases with an increase in amount of water. This is very common. The strength of soil generally or often decreases when water is added to that. To soil pores, when water reaches soil pores, and in pressure existing in pore water, presence of more water in saturated soil, if saturated soil, its full its contents of water full, it's called, more water is added. It's a saturated soil. It's increases interparticle distance. It increases interparticle distance of these particles. And when interparticle distance increases, this means becomes a weaker soil. It gets less strength. It loses its strength. It's called weak soil, and it bulks in volume. Addition of water to clay, addition of water to clay reduces cohesion, because clay is a cohesive material. So you can say the increase of water to clay decreases cohesion that particles have by increasing electrical repulsion, because electrical repulsion is increased, so cohesion is increased. Hence, you can say increasing electrical repulsion between particles because of cohesion, loss of cohesion. Hence, it can be concluded that water is an effective soil lubricant. water is effective soil lubricant by draining of moisture. By draining of moisture from a soil mass, absorptive forces holding particles under compression increases which in turn improves. Well, say that draining the moisture from soil mass, absorptive forces holding particles under compression increases. When you take out water from soil and compress it, what do you increase? Which in turn improves the strength of soil. Following four methods of soil drainage are here. 4 methods. Application of external load to soil. Application of external load to soil. So application of external load to soil mass to squeeze out pore water. Most commonly used load is an earth surcharge. Earth surcharge on that for long. Then drainage of pore water by gravity or pumping or both. Then you can say by applying electrical gradient, you can do that. Then application of thermal gradient, you can do that. So what is given here? In this drainage, take out water from the application of external loads. Application of external load to soil mass to squeeze out pore water and earth surcharge is source of that. Drainage of pore water by gravity or pumping of both by applying engineering and by application of thermal gradient. And see that is this plan. Why is showing this? People are sending messages everyone. It says आपकी जिंदगी का सोलफुल है. Somebody sent some message, some kid. I was just trying to watch that. By application of electrical gradient, by application of thermal gradient. Let's move further. Granular stabilization. Granular, GRA and granular stabilization. Two major functions of a pavement is to one, distribute wheel load is such a way Then say two major functions of pavement is distribute V load, distribute V load, distribute V load in such a way that load transmitted to subgrade is within limits of bearing capacity. When you transfer load to subgrade and within bearing capacity, you can use this. 2. Resist transverse force near surface due to wheel movement. Now granular material, granular material such as crushed rock, let's say crushed rock, gravel and sand, due to internal friction, provides enough shear strength to distribute wheel load. Granular materials such as crushed rock, gravel and sand, due to internal friction, provides enough shear strength to distribute wheel load. Now you can say, however, such material also lack in cohesion, which is needed for resisting lateral forces at surface. Cohesive soils provide certain degree of lateral resistance, but turn out to be too soft when wet to carry load. It's same thing means cohesive is clay. When it comes in contact with water, it loses its strength. That's the problem here. Now, it says provides certain degree of lateral resistance, but turns out to be too soft when wet to carry weight. Carry load. Primary principle of granular stabilization is it's judiciously combined granular material with cohesive materials and then provide both cohesion and internal friction to pavement. So now we go forward, see something very important. We say primary principle of granular stabilization is a judicial combined granular materials, with cohesive material and thus provide both cohesion and internal frictions to current. Now it says a series of 10 sieves is 10 shapes. Wait a minute. These stages are involved in granular state surface. What are these? The stages that's involved in that. That is power blending in granular stabilization we are talking. Power blending, proper blending. Then there is compaction. So proper blending, compaction, proper maintenance, 3 stages. Blending, compaction, and proper maintenance, moisture, and stabilized pavement. Okay, no problems. Let me smile. What I can do, because of lack of sleep happens, but I can't help it. I'm getting fan. That's it. So I don't have a very comfortable area here. What to do? So these are 3 points. You have to bend properly, blend, compact properly, and proper maintenance of moisture of stabilized pavement. A series of 10 sieves. A series of 10 sieves. Use 10 sieves. ASTM. A series of 10 sieves ASTM seam 2 inches, 1.5 inches, half inches, 2 inches, 1.5 inches, 1 inches, 3/4 inches, number 4, 10, 20, 40, 42. Oh my God, your messages, I'm fed up here. Says number 4, number 10, number 20, number 40, number 200 or BSU 3 inches, 1.5 inches, 3/4 inches, 3/8 inches, 8, 3/16 inches, number 17, 14. See, the numbers are there. So we can say British shoe 3 inches, 1.5 inches, 3/4 inches, 3/8 inches, 3/16 inches, number 7, 14, 25, 52 and 200 or their equivalents of ISCs are used to obtain where is it? Now these sieves are used to obtain this design measure. Now we have given two series, ASTM serial number we have seen, BSC we have seen. Now this is applicable and their equivalent of I is 18. Series are used to obtain 200. Also, certain proportions of dissolved designated mixture must be returned. It says a granular soil mass attains a very high density after compaction. If distribution of particle sizes are used to decide a granular soil mass attains a very much if granular soil mass attains a very high density after compaction, if distribution of particle size is that following Rule-Fowler law. Yeah. Now, percentage of particle size. Percentage of particle passing any seal. You can see this formula, and this is percentage of particle passing any seal equal to under root D capital over D small into 100. This is approximate size of particle sieve, D capital 1. Approximate size of now table 23 on now. Approximate limit of particle size, approximate limit of particle size distribution for base and surface courses, ASTM, mechanical stabilization. Now what it says? This is a table here. I'll show you before reading it. Now in this column are one is ASTM sieve distribution, then this person is passing, and there is within that, under that person passing. ASTM sieve designation is ASTM sieve the space, then there is a person is passing other one, and if person is passing itself, there is graduation A, that is sorry, gradation A, there is sand, clay, base or surfacing, and other one is, that is gradation A, gravel, sand, and we'll go through that. In that, then that is gradation A, that is gravel, sand and clay, and base 2 inches maximum size, 1 inch maximum size, and surface. Now it says in this, now this ASTM 2 inches, 1.5 inches, and 3/8 inches, and 3/4 inches, 3/4 inches, 8 to 8 inches, and then sequence in them. You may be saying, I'm sleeping, huh? No, I'm not sleeping. This subject is like that. You try it. You try it. You will not read it, I'm telling you. You will not read it. Boring, very boring. Something people don't want to discuss this. I want to relax a little. Relax. I want to relax. Let us relax and talk. 2 inches, 1.5 inches, 1 inches, 3/4 inches, 3/8 inches, number 4, number 10, number 20, number 40, number 200. This is ASTM sieve. And ASTM sieve, the gradation A, sand, clay, base or surface. Nothing up to number 4. The number 10 is 100. That is gradation A, sand, clay, base or surface. This is 100 when number 10, 55, 90 when number 20, and this is 35, 70 when number 40, and 8, 15 when number 20. After that, gradation A, gravel. This was gradation sand, clay, base or surfacing, and in case of gradation A, gravel, sand, clay, gravel is added to sand, clay, base. Here gravel, sand, clay, and it is base. This is 2 inch maximum size and 1 inch maximum size. Then surfacing, and then gradation C, base or surfacing. What it says now, in base 2 inch maximum size, it says 2 inches 100, 1.5 inches 70 to 100, 1 inch is 55, 85, and then it is 1.25 inch, 1 inch, 3/4 inch, 650, 50 to 80, and then it's so 2 inches 100, 1.5 inch 70 80, 1 inch 58 55 85, then 3/4 inch 50 to 80, and there's a percentage passing, I'm just telling you, and this is 3 8 inch 1 2 3 4 5 3 8 inches, this is 40 to 70, and number 4 is 30 60, number 10 20 50, number 20 something, number 40 is 10 to 38, number 200 is 10 to 25 to 15. Then surfacing, nothing in 2, nothing in 1.5, and then one is 100, then 3/4 inch 8500, then 3/8 inch 6500. You go to number 4, 55 85, and number 10 40 to 70, then nil, then number 40 is 24 to 25, number 200 is 10 to 25, and gradation C, base of surfacing, it's now only 3/8, this is only 3/8. You say in number 4, this is 55 85, number 10 40 70, number 9 is 84 45, then you go to gradation, also nothing up to in 3/4 is 0 1. So you scrap that was this, and 100 passing is 3/4, 3/8, and then you can say 70 to 100 passing is number 4, and 10 pass, number 10 is number 10 is 35 85, and then number 40 is 18 55 50, and then 60 40 40, then this is nil, number 20, and this is. We go now to, I would say, 80 to 50, 80. This table 23 on this table shows American tentative limits of particular size distribution for base and surface courses. Now, gradation among A, B and C may be used depending upon maximum size of particles. Right? Any one gradation among A, B and C may be used depending upon maximum size of particles available. Soil mixture obtained from these gradings agree considerably with Fuller's law. It's Fuller's law. Sorry, gentlemen, sorry. The soil mixture obtained from these gradients agree constantly with Fuller law. Gradations illustrated are used with certain limitations. It's beyond the scope of this book. Okay, leave it. It's essential to mix soil of site with appropriate quantities of one or more. These gradations are used, the gradation illustrated are used with certain limitations. However, we can do that, we understand that. It's essential to mix soil of site with appropriate quantities of one or more imported soils in such proportions that mixture of soil obtained coming in now we have to mix some other soils. It's so essential to mix soil of site with appropriate quantities of one or more. It is essential to mix soil of site with appropriate quantities of one or more imported soils in such proportion that the mixture of soil obtained conform to gradation A, B or C. Following are some of methods followed for each such a mixed design. The method of trials based upon C analysis and based on plasticity index and geographical methods. You understand these methods? That's point. People, it is killing, really. It is killing me. How to do it? How to have this? Trial. What is method of trial? Method of trials. A number of mixtures of local soil and imported soil or soils is prepared in various proportions based on experience. Tests are conducted with such mixture which fulfills gradation requirements and plasticity requirements is finally selected. This is very important one, because when you are getting imported material for purpose of mixing with available soil that you have, just to increase or upgrade its mixture content, upgrades its proportion in such a way that it attains after getting good to further. So that's trial and based on experience. Then it's based upon sieve analysis. Based upon sieve analysis, materials are proportioned either by making use of some mathematical formula or by using graphical method, such that grading of moisture After that, based upon C analysis, number materials are proportioned either by making size of some mathematical formula or by some by by using graphical methods such that grading of mixture bank fulfills desired status. So mathematical formula or mathematical charts or graphs, so grading of mixing fulfills desired specifications or desired. Such a sample is tested for liquid limit and plasticity index, whereas something fell, I think. I don't know. Right, we will also turn off for 5 minutes. And it's disturbing me today. Why? I'm also thinking such a sample is tested for liquid limit and plasticity index must be in accordance with requirements of mixture. Plasticity index. Plasticity index, based on plasticity index, materials proportion with help of a formula. Materials proportioned with help of a formula using tables such that plasticity index of mixture is within this required range. Trial mix after keeping being tested for PI is also tested for appropriateness of gradation. यार जाओ ना यार, क्यों तंग कर रहे हैं मेरे को डिस्टर्ब करके हल्के यार, खाना खाने से ले जा रहे हैं यार, हजारों इकट्ठे कर रहे हैं यार, कोई रिस्पॉन्ड नहीं करा फिर भेज जा रहे हैं, क्यों भेज जा रहे हैं समझ जाता नहीं यार, फालतू लोग बैठेंगे रोने. So plasticity index, material proportion with help of formula or using tables such that plasticity index of mixture is within required range. Trial for mix, trial for after being tested for PI is also tested for appropriations. Come on now. So trial mix being tested for PI is also tested for approximation of gradation. Graphical methods. So our methods here which we have to understand is very, very, very boring subject and boring topic. We are going to soil stabilization. There are a number of graphical methods, but Roth-Fuchs method is most suitable. It's reasonable, it's really quick and simple, and it's used for mixed design for any number of ingredients. Cumulative curve of required particle. There are a number of graphical methods, but Roth-Fuchs method is most suitable. Roth-Fuchs method. It's reasonably quick and simple, and is used for mixed designs of number of ingredients. Right? Cumulative curve of required particle size distribution is called plotted by selecting a scale of sieve size in a manner that particle size distribution plot is a straight line. And then what to do? Cumulative curve of required particle size distribution is plotted by shifting a scale of sieve size in a manner that particle size distribution plot is straight line. On same scale, particle size distribution curves of aggregates to be mixed with are placed. A straight line that resembles most closely to particle distribution curve of single aggregate are then drawn by selecting a straight line for each curve. On same scale, particle size distribution curve of aggregates to be mixed are plotted. Straight line that resembles most closely to particle distribution, particle distribution. Straight lines that resemble most closely to particle distribution curves of single aggregate are then drawn by selecting a straight line for each curve and such that areas in those between it and curve right? A very important point here. I'm going to explain this because this is a complicated one here. Now, enclosed areas, the areas enclosed between it and curves are a minimum and balanced about straight line. The opposite ends of these straight lines are joined together and proper proportion for mixing are read from points where these joining lines are like cut straight line representing required mixture. Once again, because little confusing it is, let's again read this. I read it fast and you can understand. I'm reading graphical method. I read again all. There are a number of graphical methods, but wrought first method is most suitable. It's reasonably quick and simple and used for mixed design of whatever number of ingredients. Cumulative curve of required particle size distribution is plotted by selecting a scale of sieve into It's reasonably quick and simple and used for mixed design of any number of ingredients. Cumulative curve of required particle size distribution is plotted by selecting a scale of sieve size in a manner that particle size distribution plot is a straight line. On same scale, particle size distribution curves of aggregate to mix and plastic. And then one on same scale particle size distribution curve of aggregates to be mixed are plotted. Straight lines that resemble straight lines that resemble most closely to particle distribution curves of single aggregates are then drawn by selecting a straight line for each curve such that areas enclosed between it and curves are a minimum and are balanced about straight line. Now opposite ends of this straight lines overlay. Now let's move to next stop of this. Same one, but next part of this. This is a very difficult one. This is. In all methods of mix design, trial mix is prepared and checklist for gradation. Plasticity, checklist for gradation, plasticity characteristics are also determined after passing soil from AS screen number 40 BS number 38 same. That's what it and that's what it. Okay. Plasticity characteristics are also determined after preparation of soil. Now, says that for base LL should not be more than 25 and PI not more than 6. These are very important. No. Liquid limit LL should not be more than 25 and plastic index not more than 6. Is for base. For surface, maximum allowable value of LL is 35 and PI being 429. Point of base. Actual procedure shall be more clear from examples. Let's see first what I said here. 25, 35, 6 and then plasticity. Before is liquid limit, that is 25 set, then 35 set. Other one, so what it says, plasticity characters are also determined by passing soil from HTM. This saves number, this is number 40 or PS number 36, which is given here, 40 is given here, 36. CVA equivalent for base LL should be not more than 25 LPS, that is number here. Now let's go to the next page and see what actually I want to say. Now it's an example. Is that what is this? It says this table illustrates, is a table given here, particle size distribution of a crusher run stone. A sand and silt clay, it is required to mix in order of production method mechanically. These are very technical and boring rules. We have to digest this. It's required to mix, it's done to sand and silty and it's required to mix in order to produce a mechanically stable surface with HTM limits if required sizes. Distribution is as given below. Crusher run stone is 38%. Okay, now what it says crusher run stone is 38%. Sand is 43%. Silt clay is 19%. How to do it? Crusher run and sand and silt clay. Now this table is giving base BSU size, aggregate available are crushers run, sand and silt clay. And what is that? This is the problem of 1 inch, 3/4 inch, 3/8 inch, 3/6 inch, number 7, number 36, number 100. Crusher stone is 96, is 96. Okay, I have to take this table now. Very well. You have to see this table first of all. Difficult in the book, but you can't problem is that good एक भी कॉपी अवेलेबल नहीं है. I read it now. BSU size 1 inch, 3/4 inch, 3/8 inch, 3/16 inch, number 7, number 36, number 200. Crusher run now says in 96, 72, 22, 12, 8, 3 and trace. Sand is then 3/16 inch, 100, number 7, 84 and number 36, 52 and then nil. Then it is silty clay in number 200. The above problem may be selected, solved in following steps. What are those steps? See, question says 38, 43, 19 sum up. You will find that it's 100 total, right? So in crusher run, when you run, say it is 1 inch goes 96 down, 3/4 goes 70 down, like this goes and happens. Then in sand, it 3/1600 goes down, then 84, 52 like this. Now required size and distribution is represented by diagonal radius of machine. Only one. What to solve this problem? How to solve this problem? What's that problem? This problem will be solved the following way. There are 1, 2, 3, 4, 5 steps here. Let's read by one. Don't be fast. Slow one. Required size distribution is represented by diagonal DDs of rectangle. Figure 2.1. 23.1. Says diagonal DD of rectangle. Now, vertical, the ordinate of this rectangle are graduated for percentage 0 to 100. This is clear. Required size distribution is represented by diagonal DTs of rectangle. Vertical coordinate of rectangle are graduated for percentage from 0 to 100 on linear scale. Horizontal scale for sieve aperture size is graduated of for drawing hard line for each side. So there's a confusion here. I think vertical ordinate of rectangle are graduated for percentage from 0 to 100 on a linear scale. Horizontal scale for sieve aperture size is graduated for drawing for each sieve size a vertical line that cuts the diagonal at point when ordinate equals to percentage passing sieve 100% for one 92, 34, 80, and so on. Percentage passing, okay, this is percentage passing is 0 to 100, and then it is it's okay, it's this figure 1. But clearly it's not written, it's a very small font is given here. So required size distribution is represented by diagonal DDs. D, this diagonal, where is D and where is D? D is shown. This D is here and D is here, I think. D is, let's see this misprint here. This is the misprint here, that's all. I think that's causing my reading problem. Otherwise it's okay. D is diagonal. So required size distribution is represented by diagonal DDs of rectangle. This. So vertical ordinates of rectangle are graduated for percentage 0 to 100. So this is 0 to 100 here. On a linear scale and horizontal scale for C aperture sizes, graduate for drawing for each C size a vertical line that cuts diagonal at point where ordinate equal to percentage passing through this, and so on. So and this side you see sieve size is starting from from here 200, then 36, and like that, This is if you see from right side 1 inch, 3/4 inch, 3/8 inch, 3/16 inch, 7 inch, and 36 number, 7/3 number, 36 number, 7 number, 36 number, 200. It's going from that to this. Now what happens here says that 0 to 100 is a passing percentage, and this is your BSS sieve size, and there is diagonal connection here from 100 down in this, this crusher run and sands and so down here. Average required size distribution. It's graphics actually. You can see this, what I mean. I'll show you first of all this point, that is, my God, ये उठाना बहुत मुश्किल बड़ा भाई, क्या करेगा इसको? हट जाएगा कुछ नहीं बना. You can see roughly this, this is the diagram. The figure is giving. This figure is D. This is here is this figure. In diagonal there is, and you see on left, on x-axis, this is percentage passing. Oh, sorry, on y-axis percent passing, and on x-axis this is sieve numbers, sieve sizes. If you say on left, it is 200, on right, and it is starting on, and it's 0 to 100 are on y-axis, or you can say ordinate, and abscissa is in number C. There is a diagonal in between, the DD dash, and graphics is like, let us see what does mean further. Now it says on diagonal, here is this, and it says then horizontal scale is this and vertical scale is that. Now it says horizontal scale for sieve aperture sizes, graduated for drawing for each sieve size a vertical line. So this is a vertical line on each sieve size, and this up there. And then what it says, a vertical line exists, cuts diagonal at point where all units equals percentage passing, that's 100% for 1 inch. This is 92. So these are those points, says is cutting diagonal at point, horizontal scale or sieve aperture size is graduated for drawing vertical lines, and where it is diagonal at that point, it is that point equals percentage passing that sieve So you can say approximately here, let us say at 1 it passes full, and that is so 100% for 1, it passes 100% for 1, and 92% for 3/4, 92% for 3/4, alright, and 82% for 3/8, 82% for 3/8, then and so on, like that, so on it says, means 3/6, 3/8, 3/6, 7, so it is somewhere more than 45, this is at 0.7. Then number two, this was number one. Number two, size distribution of aggregate. It's a little very confusing, but it's okay. It's a misprint actually. There was size distribution of aggregate to be mixed. There is table 23.3. We'll say this is table, and says that in this it says also BSC, same notation as in that table 23.2, 1 inch, 3/4 inch, 3/8 inch, 3/16 inch, 7 number, that's quarter, and required size difference limits and average is there. Then aggregate available A, B, C, crusher, stone, sand, cylindrical area, percent passing, and mixture is A38 as given there, A38 and sand, and this B43, and that's, and C is 18. What's given there is 10, and say it says the passing through required size. This limit is 100 to 10 to 5, 1 inch 100, 3 inch 84, 100, 3/8 inch passing 64, 10, 100, 3/16 inch passing 53, so 87, and number 7 passing 38, 7, 20, number 36 passing 25, 43, number 20 passing 10, 25. This is limit, and average is number 1, 300, okay, 900. And then there is, then there is average. This is 100, 92, 100, and this is 92, and then because of 84 plus 100 is 184, and 92, 164 is 82, and then 140 is 70, and 108 is 54, 25, 40 is 34, 10 to 25 is 18. This is average here. In the average, then aggregate available A, B, and C. A is crusher stone, crusher and stone. This aggregate available, and these are size distribution. Before I told you the sand, and these aggregates are available in 1 inch. There is 96, 3/4 is 72, 3/8 is 22, 3/16 is 12, 7 is 8, 6 is 3, and then trace, and B is about 3/8 is 100, 7 is 84, 36 is 2. So this is table, other table. Now voice link, I am linking these two. I am linking this in a way that what we discussed there for this table figure 21 to just link with that. So say size distribution, there is size distribution of aggregate to be mixed. Table 23.3, column 7, column 7, that gives it result as 1 inch 98, 3/4 inch 89, 3/8 inch 71, 3/16 inch 67, number 7 is 57, number 36 is 41, number 200 is 10. So size distribution of aggregate to be mixed in this column 7 are plotted on this scale of sieve size, giving line BAD crusher on BFE sand and DG silty clay. And let us see where is that. It says here in the same figure 23.1, this table 23.3, these are linked. So we can see what's that. This says giving line BAD, BAD is here on lower side of that diagonal, BAD, which is crusher on BFE is above. This is sand and DG silty clay. DG is silty clay, D. That is DG. Silty clay, BF pressure run. Nearest straight lines to these sizes distributions are drawn with aid of transparent straight edge by minimum balance. This is water, a little tossy. very much technical it is now. Very interesting one, believe me, it's interesting one, technical but interesting for me. I don't think we're going to be that daft. So I'll show you the graph again. So the nearest straight line to these size distributions are drawn with a transparent straight edge by minimum balance areas. A method described earlier. There are dotted lines CD. They are dotted line CD. Okay, CD. BP, CD, BP, fine, and got is DG, D, and D, DC, where's DC? DC or DG? Well, I think it should be D. I think this is writing error. It should be DC. Yes, it is DC. I think not GDC. Last being coincident with actual size distribution. So these are the nearest straight lines to these size distributions. So nearest straight line to these size distributions they have shown are drawn with aid of transparent straight edge by any minimum balanced areas method described earlier. So one is that and one is this. So I see this nearest edge line, this, and this is the nearest as well as this. That's that, okay. And then we connected this point with this point. We connected this point. The opposite end of these lines are joined, giving a chain line CP. Chain line CP and BG, CP and BP, CP and BP, CP and BP. Opposite ends of these lines are joined, giving chain line CP. Okay, where's PG? That's my question. B. Okay, this looping. In this case, later coincides with number 200 PS. This is that. Let us this number. Points where these lines cross required size distribution line are marked by circles L and M. These circles L and M. This is small circle L and this another circle we are saying M. These are two circles. Okay. This point and this is meeting here on diagonal. This is meeting. So this is coming here. This starting here, and then I see. This line is here. This line is getting here. It is this the point where these lines cross required size distribution lines are marked by circles L and M. Proportions in which three aggregate proportions in which three aggregates should be mixed. Proportions in which three aggregates should be mixed are obtained from difference between ordinates of these points and are shown on right hand side of figure 23.1. So this is that is clay, silty clay is this one, okay, and sand is this one, and crushed ram is that. So sand is there, proportion which this aggregate should be mixed or obtained from different between ordinates please. Vertical size distribution that shall result from mixing aggregates in these proportions is here in column 7. Column 7, okay, then of table this, although it's not identical with the required size distribution, columns 4, 5, 6. It's within specified limits in column 2. On this, okay, it's 89, okay, so it's fine. No. Okay, this all says, and so let me first give you this this is sketch again. Let me set a sketch again. This is what you see. If you look again, this graph comes to you, and with the table here, that's detailing this one. This table and this graph are both connected. This figure. In this, as I said before, there are diagonal connection, opposite end, and bottom and verticals are different. In this, maybe vertical is passing, this, what is called it, percent is passing and bottom is BSU size, this diagonal is there, and then there are two curves here, upper side and one side is sand upper side and down side is average required size distribution, and crusher run is there. There are three, and these are, you know, this is a graph used for purpose of finding out way in which these lines are drawn, and then further lines are drawn. One line is drawn for this purpose, and say procedure saying I'll first speak this procedure again, and you then check this graph. I'll speak this procedure again because this is very, very clear but complicated. Again, it is that there's a question, there's an example here. This tries to let us understand how to you can say mix various available stock you have in site, and you have to add imported material in certain percentages. You have to mix so that we can mix that way to get our aim, or you can say this is kind of an engineer mix. Example here is table 20 illustrates particle size distribution, which is that table 23, and particle size distribution of a crusher run stone. Crusher run stone is sand and silt clay. It's required to mix in order to produce a mechanically stable surface within ASTM limits. If the required size and distribution is as given below. Crusher run stone is 39%, and so here you can say it is required to mix in order to produce a mechanically stable surface within ASTM limits if required size distribution is given below. Crusher run stone is 38%, sand is 43%, silt clay is 19%. If you see total of this 38 plus 43 plus 19, it is 100. 8 and 11, 9, 20, balance is 2, 3, 5, 4, 9 and 110. This is 100%, and there's a table given here which is BSCU is 1 inch, 3/4 inch, 3/8 inch, 3/16, 9, number 7, number 36, number 200. Then the crusher run is 96, crusher aggregate available are 1 inch 96, that is crusher run, and sand nothing and silt clay nothing. 3/4 inch crusher run is 72, sand is nothing, silt is nothing. Then 3/8 inch is crusher 22 and remaining nothing. 3/16 inch crusher is 12, sand is 100 and then nothing. Then number 36 is 3, crusher run is 3, and number 7 crusher run is 8 and sand is 84. Number 36, crusher run is 3 and sand is number 200. So this is tabulation of that. You first see this tabulation so that at least you clearly understand what we're talking of. I'm just giving you a glimpse of this only. You can see that on left there. I think this maybe this side, right? Yes, this is these. These are 3 materials we have: crusher run, sand, other one. These are percentages which are giving me total. You can see that, and this is your tabulation of this. This is how we have to add this material together to produce a better material. This is what is required. This is an example. Now we'll go further onto this. What to do? This is really a kind of tutorial. Now this is a problem we will solve in following work. Means we have to mix up these materials, how to match, how to find graphically this. Now say there are steps in this. I gone through before. Now I'm going with different speed because they are, previously were like analytics and now we are understanding that. Now required size distribution is represented by diagonal DDs of rectangle. Required size distribution is represented by diagonal of this rectangle. Now which diagonal is that? This diagonal, I'm talking of this diagonal. So this is a, you know, this is a diagonal here. You can see D in this rectangle is I showed is a D here. This is a D, this diagonal. I'm showing to D, and other one is other corner is D dash. This is diagonal. And it further says that it says vertical ordinates of rectangle. Vertical ordinates of rectangle are graduated for percentage 0 to 100 on linear scale. So you can say x left side of the same graph, left is percent is passing, and you can say abscissa is BS sieve size, and it starts from right side 1 inch, 3/4 inch, 3/8 inch, 3/16, 7, 36, 20. I have 0, 20, 40, 60. This you can see again for your clarification, because you can see this on vertical it is, you can see 0 to 100% is passing, and here sorry, this is, you can see BSCU size starting with 200 and going on right side to smallest one, size of 3 inches and then numbers. This is your abscissa and ordinates. This was says now, this is all linear scale, and that that was vertical is linear scale. C aperture is graduated for drawing for each C size vertical line that cuts diagonal at point where. Now, because we have taken diagonal, we have taken horizontal line, vertical line. Vertical line is passing through C, passing through C. Horizontal lines abscissa is for C sizes. Now I says wherever C number is coming, let's say number 1 inch, we put there's a line vertical on that. Then 3/4 we put a vertical line on that. 3 inches we put a vertical line on that, and then 3/16 we put a vertical line on side. 7 inches vertical line on 36 with a vertical line. 200. Now their vertical lines are every number of C on 1, 2, 3, 4, 5, 6, 7, 1 inch, 3/4 inch, 1 inch, 3/4 inch, 3/8 inch, 3/16 is 7, 36. There are 7 vertical lines put on that. These vertical lines crossing at diagonal, right? These vertical lines cross at diagonal. We get points at diagonal. Now those points refer to that percentage radiating on shield should be much. Say that, right? So say says horizontal scale for C aperture graduated for drawings for each size vertical line that cuts diagonal at point. Occurs at point where alternate equals percentage passing that shape. Means that percentage where the diagonal lines come by vertical lines, that the percentage passing through that shape. Right? Vertical line that cuts diagonal at point where alternate equals percentage passing that shape, namely 100, that's 100% for 1 and 92% for 3/4, 84% for 3/8, and so on. So this we can achieve this equation. After that, we got this information points cut on line, diagonal line, that person of the passing the seeds on these lines. Now, size distribution of aggregate to be mixed. Size distribution of aggregates to be mixed. Table 23.3 is somewhere else, column 7 are plotted on this scale of same size distribution of aggregates to be mixed. That's table. Next table, show you this table. This is table first before I show you before again you will see, so that no confusion exists. And this is that table, and this is below this, and this is that table here. You can see this table, and there is 7, 6, 5, 4, like that. Columns and titles are these, and this table indicates telling table 23.3, and this is what it's saying. We are going to combine this now. Now it says size distribution column 7 are plotted on this scale of serial number figure 23.1, giving line BAD, let's say line BAD. These percentages on serial line it is, this is 1 inch, let us say 1 inch goes to 98. 1 inch, at 1 inch it goes to 98. That is on diagonal, near diagonal, and 98. Then it goes to 3/4 inch, it goes to 89. 3/4 inch, 3/4 inch goes to 89. Okay, then you can say 3/8 inch goes to 71. 3/8 inch goes to 81. DAB says DAB. Let me understand here again. Size distribution of aggregate to be mixed. Size distribution of aggregate to be mixed. 43.3. Column 7, this is column 7, are plotted on the scale of sieve size 23.1, giving line BAD dash, BAD dash, BAD, that's okay. Crusher run. BAD is crusher run. BAD crusher run. BFE sand, BFE sand, okay, BFE sand. DG is silty clay, DG is silty clay, DG is silty clay. This is the side. A, B, C, D, F. That is DG here somewhere. Only point is missed actually. Point is missed. DG here. It's here, I think it should be here. Yes, line BAD is there, and line BFE is there, and line DG should be here. This actually, where's my line DG? It is there, DG should be there. It's missed actually, I think so. Well, then we go nearest straight line to these, nearest straight line to these sizes. Voice says this line is plotted here. Once 100, 3/4 inches, 90, 92, 72, 3/4 inches, 72. Wait a minute, 3/4 inches, 70. Yes, that's okay. That's okay. This one is that crusher run. So this is line of crusher run, and this gives you 96A, 96A. This is B, and this is C. "96 is here, that's okay. 96 is here. 3/4 inches, 72. 3/4 inches, 70, that's fine. 72. Then 22 is 3/8 inch. 3/8 inch is 22. That's fine. 3/16 is 12. 3/16 is 12. Number 7 is 8. Number 7 is 8. Number 36 is 3. Number 36 is 3. Number 200 is 6. Number 200 is 3. So 0. Alright. So this is that line. So the graph is actually a little mistaken, you know. In this 72 it's saying at 3/4 inch. 3/4 inch is saying 72. 3/4 inch is 72. Here actually 3/4 inch is 72. It's more than 60 here, but that's I think an error, graphical error. Well, that doesn't matter. After that, if you see sand line, I will find that sand. It is 3/16 inch 100. 3/16 inch, this is 100, that's okay. Then line number 7 is 84. Number 7 is 84, that's fine, 84. Number 36 is 52. Number 36 is 52, that's fine, okay. But it's a higher side, only no problem. It's 62. Then number 200 is nil. It's okay. And go to silty clay. That is number 200 is 100. Number 200 is 100. So it's here. So this point is here. Exactly, this is O and D. In fact, is Miss Samir got it now. So it's that point which is mentioning as DG. So this is D, and G is here, which is missed. That's all. I'll put DG here. I think say this is DG actually. DG. This is G. Right? This is G. Okay, that's DG. I'll correct it that one. Alright, so this are 3 lines, 3 curves. We have 3 lines. Line, you can say D, DAB, that is DAB, or BAD, anything you can say. Start B is at BX, so BAD, that is crusher line, and BFE, that is sand line, and DG, that is your that is your what do you call it, silty clay. So we have 3 lines here, full lines. Now what I say, these full lines I'll show you. It's better because this is very intelligent study actually. This is very intelligent study we are making. If you see this line, this is called this B, and his A, and this is top one. This is crusher line, and this is B, and this is a top F. This is sand line, and from top D to this J, this is silty clay. These 3 full lines are there, curves are there. Now we have to find near line to this. That's what's requirement. Near line was says nearest straight lines to these distributions are drawn with aid of transparent straight edge, okay, by minimum balanced areas, minimum balanced areas, uh, minimum balanced areas method described earlier. They are dotted line CD. This dotted line CD. So this is that line. CD is one line, and then this BP is another line, and then DG, 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 what's your DG? DG another line. Now it's this line, DG. Last being coincident with actual size distribution. DG last with which actual size distribution are marked by circles L and M. Now circle L and M. L is here and M is here, circles are here. Element, okay, these are distributions here. You can see these here lines. You can see equivalent area line or approximation of area lines. You can see dotted lines here. You can see this dotted line starting from this, going parallel to that and meeting down at abscissa, and here another one, same line. And there's another one here. These are near area line, near parallel lines for area. And there are two circles shown on diagonal. One is this, and other one is here. This is M, another, I don't know what's that. And this is two circles are shown here. So what says now? L and M. L and M, these are two circles shown. So opposite ends of these lines are joined. Say opposite ends of these lines are joined. P and C, these are points. Opposite ends of these lines are joined. What a fan also. It's 335, it's okay. So it says that nearest straight lines to these size distributions are drawn with aid of, by minimum balance areas. So these lines are dotted lines we are drawn, that is DC and BP. DC and we are drawn that, and the CDBP and DG. Alright, so now last being constant, now say with actual size distribution now. These three lines are there, dotted lines are there. Opposite ends of, now these are three dotted lines with dot, then dot. Opposite ends of these lines are joined. These opposite ends of these lines are joined. These are two lines, opposite lines are these. L opposite ends, these lines are joined. So L and M. One is actually not dotted, it's not seen, but L is meeting here on diagonal and M is meeting on diagonal. These two lines, PC is one line, GB is another line, and 2 points we got in this L and M. L point is created by by joining that there's a G, or you can say silty clay connection, and this is PC. This is connection between sand and crusher run. So these 2 points, L relates to connection between curve, between this line of sand and silty clay connection L, and M relates to connection between crusher and sand. So these L and M point we have generated, and we can see L is lower one and M is higher one. L, when you draw a line, horizontal line parallel to abscissa at L and M, you get these two lines. I'll find when L is horizontal, this is the limit of silty clay, and M is horizontal, this is the limit of sand, and upper one is crusher one. So we have three divisions in that. One division is silty clay, that's up to L line, and sand up starts from their L line and goes to M line, and then crusher run. These are three combinations we have. And if you go further, this it says after the opposite ends of these lines are joined, giving chain CPBG in this case. Later coincided is number 200. See all the points where these lines cross required size distribution are L line among L and M, proportions in which in these three aggregates should be mixed. Proportions in which three aggregates should be mixed are obtained from differences between coordinates of these points and are shown on right side as I just discussed. I'll show you particle size distribution that result from mixing, particle size distribution that shall result from mixing aggregates in these proportions as given in column 7 of table 23. Okay, although it's not identical with required size distribution, columns 4, 5, 6, it's within specified limits, column 2, and this 7 says if you are talking of particle size distribution, and result is this is because we procured in A is equal to 38 as before, crust run stone 38, B this 43% sand run, and silt is 18 minus 1, and we will say 1 inch we have to take 98. In this result is that particle size distribution, and that is BSC 1 inch 98%, 3/4 inch, I'm saying 98% passing, 1 inch 98% passing, and this all these metals I'm talking of, particle size distribution. Then 3/4 inch 89% passing, then 3/8 inch 71.8% passing, 3/6 inch 67% passing, number 7 57% passing, number 36 43% passing, and number 200 is 19. This is particle size distribution, and this I'll show you again for last wave in this method. It's an important one. And this is your graphics. As I showed to you, these points we got L is indicated by circles and M. This horizontal line you can see abscissa, you can see abscissa parallel to abscissa. Number top is, and then there are three distributions are here. Number ground is silty clay, then sand, and then crusher run. These three are proportioning of this, and we have to find particle size because we got these points from L and M. L is horizontal line, the other line is L indicates, as I said before, between silty clay and other one sand, and then the M is sand and crusher run. This 2 points gives this one, and then after that we have to set that this here table, which is result of this. This is, you can say, this is result of 7 as 98, 89, 71, 67, 47, 43, 19. These are percentage passings, and this is here in this seed size is 1 inch. Okay, I'm just giving 1 inch, 3/4 inch, 8 inch, 1/6 inch, 16 inch, 6 inch, and then you can say remaining 7 number number. The relative points of size distributions of this, which is also falling between range of this, so 96 here, 196, 72, and still the same 98. The range is this 3/4, and this is saying that pressure. So this what we are getting out of this result is particle size distribution as number 7 announced. This is what is mixing of different. This is mixing of different. The method is method of trial based upon CV analysis, based on plasticity index. So this is very important practical method. Well, it's a little complicated, but it's essential. You don't have soil, you have to produce certain design soil. It's like concrete. You have to decide proportion of different materials. You have to import some material from other sources according to this, or whatever is available. You import that and you find out percentage of various mix so that you get demanded FIDIC, demanded density. It's called engineered fill design. Then you have to fill it engineered wise. Engineered fill is called, and for that engineered fill requirement, you have to decide fill. This is not easy. People do not do this, but this requires. This is required. It's not simply for purpose of learning, it's for purpose of doing. This is height of engineering backfill. It's not so easy just to condemn it. It's to be done. It took so much just for understanding one method. It's not simply that we import something and just fill in and mix it by shovel. You have to mix it by shovel. You have to do everything, but you first have to do that. You may have to screen out all boulders, everything, and because not more than 40 millimeter size is allowed. So you have to manage different stacks. Just like here there are 3 stacks, crusher run and sand silt and sand. Then you have to make some required proportion according to this. That's why you will get this type of result. Otherwise you will not get result, or you find proportioning in that way. That's where it works. I think maybe it's clear to you. This is interesting to me because it's giving something quality based calculations, quality based method statement, how to design backfill mix, how to do backfill trial, like we do concrete ingredients trial for purpose of designing concrete mix. That's design of backfill mix. It's not something low profile, it's a part of structure. Without this, you cannot site your foundation, and if you site your foundation, you cannot backfill around because this is required. And if you can't backfill around, you cannot do anything. And that you have to get 98% proctor density, or whatever it is. This method is full guidance, and there can be managed such. So in this case, we have gone through this trial method. It's a number of mixtures of local soil and imported soil, or soils prepared in various proportions based on experience. Tests are conducted with such mixtures, and mixture is fulfills gradation requirements and plasticity requirements is finally selected. Again, I'm telling you, this is a method which says that what I'm saying is method of trial it is, and it is a part of granular stabilization. As you said, granular stabilization. Again, I read this. 2 major functions of pavement is to distribute wheel load in such a way that load transmitted to subgrade is within limits of bearing capacity of grade. Resist transverse force near this, and granular matters such as crust rock, gravel, and sand due to internal frictions provide enough shear strength to distribute wheel load. However, such methods are also lacks in cohesion, which is needed for resisting lateral forces of surface. Cohesion soils do provide certain degrees of lateral resistance, but turns away to be too small. Primary principle of granular stabilization is to judiciously combine granular materials with cohesive materials and thus provide both cohesion and internal frictions to pavement. Three stages are involved in granular stabilization: proper blending, compaction, and proper maintenance of moisture in stabilized form. So this is further beyond. I'm not going to see that. I'm going to discuss that because now table 23 is one is the approximate limits of particle size distribution of base and surface courses, ASTM mechanical stabilization. We already gone through that, but table 23 one that is and shows now gradation illustrated in 23.1 are used with certain limitations. However, it's beyond scope of the leave it. Now, method of trial. See this method. The following are some of methods followed with such mix. It is essential to mix the soil of site. It's essential to mix soil of site with approximate quantities of one or more imported soils in such proportions that mixture of soil obtained conforms to relation A, B or C. Following are some of methods followed for each such mix design. Method of trials, which is number of mixtures of local soil and imported soils or soils prepared in various proportions based on experience. Tests are conducted with such mixtures and mixture which fulfills regulations, requirements and plasticity requirements. And then based upon sieve analysis, materials are proportioned either by making use of some mathematical formula or by using graphical methods such that grading of mixture fulfills desired specifications. Such a sample is tested for liquid limit and plasticity index must be in accordance with requirements of mixture. And based on plasticity index in this method, materials proportion with help of formula for using tables such that plasticity index of mixture is within required range. Trial mix after being tested for PI, plasticity index also tested approximately gradation and go through graphical method. This is what we are talking about. There are a number of graphical methods. Rock fill methods most useful, rock fill methods, and I suggest them with quite time, simple and used for mix designs of whatever number of ingredients. Cumulative curve of required particle size distribution is plotted. It's plotted by selecting a scale of CN or sieve size in a manner that particle size distribution plot is a straight line on a same scale, and particle size distribution curves of aggregates to be mixed are plotted. And straight lines that resemble most closely to particle size particle distribution curves of single aggregates are then drawn by selecting straight line on each curve such that areas enclosed between it and curves are minimum and are balanced about the straight line. Now, opposite ends of these straight lines are joined together and in proper position for mixing are with curves. In all methods of mix design, trial mix is prepared. In all methods of mix design, trial mix is prepared and checked for variation, plasticity, characterization. Plasticity characterization are now determined after passing soil chemistry in this. What's saying is in all methods, wait a minute. I missed something. On same scale, particle size distribution curves of aggregate are to be mixed are plotted. Straight lines that resemble most closely to particle distribution curves of single aggregate are then drawn by selecting a straight line for each curve such that areas enclosed between it and curves are a minimum and are balanced about. Straight line. Now, opposite ends of these straight lines are joined together and purpose for mixing are read from points when these joints, joining lines, cut straight line from here. Yes, cuts important now. Opposite ends of these straight lines are joined together and purpose of mixing are read from points when these line cut straight lines representing required mixture. In all methods of mix design, trial mix is prepared trial mix or plasticized trial mix is prepared and checked for gradation. Plasticity characteristics are also determined after crossing soil from STM number 40 or BS number 36 sieves then you can say for base LL should not be more than 25 and PI not more than 6. For surface, maximum allowable value of LL is 35 and PI between 4 to 9. Actual procedure shall be more clear from following. So this is what we have discussed. This is an example. Now we go to cement stabilization. I think because this might have took time, I know. It took a lot of time, but this was very important to understand, because without understanding this, we can't move further. This is very much important to understand deep technology. I can say ordinary technology, but because this is too complicated, and now so this is old method. Softwares can be used to find just area, etc. That can little better, but principle of procedure of technology behind remains same. Rather than the parallel lines means that it can decide your computer can decide, program can decide which lines for you. So you may get benefit there, but here it's really very expensive. So can say we should understand all these points very clearly these days. And now we go to cement stabilization. Cement stabilization, which is also very important part. Well, I think because I was very slow, maybe I was thinking, or I was lapsing, you can say, due to certain reasons of humidity here, 91% humidity and increasing. So it's difficult sometimes. I'm using fans for that purpose, just to distribute that. And also I'm using on the fan. Just let me hold I put up the fan. Please. Extract fan for only the purpose of taking out this moisture from here. Well, now on with cement stabilization. I understand that you got some idea from this detailed talks, and you can go to boards if you wish. Maybe you don't find this method, but you'll find this method in books somewhere, and which is very practical to. One should be practical, otherwise it's difficult, deal with. So now we go to cement stabilization, and this was actually mechanical stabilization. So we go to cement stabilization first. Cement has been very useful. Of course, cement has been used successfully to stabilize granular soils, sand, silts, and up to medium plastic clays. All over the world, several thousands of miles of soil cement roads have been constructed. Major constituents of cement which have a distinct effect on the strength aspect of soil cement mixes are calcium disilicate. Calcium disilicate, if you know little chemistry of cement, you will understand. I think it's easy, it's not difficult. Calcium disilicate, calcium trisilicate, free line calcium trisilicate sets fast and is responsible for immediate strength gain. Free lime may bring about base exchange capacity and change texture of soil. This may also contribute to long-term pozzolanic action or reaction. Calcium disilicate is responsible for long-term strength due to hydration reaction. In case of granular non-plastic soils, cement may bind particles at points of contact. However, in case of fine-grained soils, particles of soils on aggregate form a matrix of soil cement with cement. As cement partly coats agglomeration prevents water from attacking clay particles. Adequate amount of cement, proper amount of moisture, high compaction and good curing are important for obtaining a good compacted strong soil cement mix. Strength of soil cement increases with increasing amount of cement. If soil contains too much organic matter on sulfate, cement would not produce proper strength. Let me repeat this because this is something chemically based, so maybe people miss. As cement has been used, everybody knows all over the world the uses and successfully stabilize all types of soils, all types of granular soils, sands, silt, clay, up to some parts plasticity clay, all over the world. And so we know there's no question of that. But what are that? Major constituents of actually there are three constituents. One we have taken is soil cement mixture, calcium disilicate. We say major constituents of cement which have a distinct effect on strength aspect of soil cement mixtures are calcium disilicate, calcium trisilicate. We are not taking aluminate here, there's a little bit also. We are taking two parts of these three, tricalcium is also there. That's a calcium disilicate and calcium trisilicate and free lime. Free lime calcium trisilicate, that is, free lime calcium trisilicate sets fast. Free lime is there, but calcium trisilicate is second material. So free lime is third one. Calcium trisilicate sets fast and is responsible for immediate strength gain. Remember, this time when these items are given, fly ash was not considered. Fly ash is also there, which you should not forget, which is in advanced stage now for this purpose. And also many other metals can be used like GGBs, etc. We'll see later on because this is basics we are talking. That's why I'm not taking that. So free lime, then calcium trisilicate sets fast and is responsible for immediate strength gain. Free lime may bring about base exchange capacity and change texture of soil. This may also contribute to long-term pozzolanic reaction. Calcium disilicate is responsible for long-term strength due to hydration reaction. In case of granular non-plastic soils means cement may bind particles at points of contact. However, in case of fine-grained soils, particles of soil on aggregate irrigated from a mixture, you can say particles of soil on a gutty, form a matrix of soil cement with cement. Uh, as cement partly coats agglomeration, as cement partly coats agglomerations, prevents water from attacking clay particles. Adequate amount of cement, proper amount of moisture, high compaction and good curing are important for obtaining, you can say, adequate amount of cement, proper amount of moisture, high compaction and good curing are important for obtaining a good compacted strong soil cement mix. Strength of soil cement increases with increasing amount of cement. If the soil contains too much organic matter or sulfate, cement would not produce proper strength. Method of mixing soil cement. Well established fact that mixtures made in laboratory have higher strength and greater durability than similar mixtures made in field, and for this sufficient allowance is provided. Compressive strength of soil cement mix increases with age and in a similar It's well established that mixtures made in laboratory have higher strength and greater durability than similar mixtures made in field, and for this sufficient allowance is provided. Compressive strength of soil cement mix increases with age in similar manner to that of concrete. It's believed that soil type affects rate of hardening, but there is definite information on this point. In practice, soil cement is cured after compaction under conditions that prevent drying of surface during the initial period of development of strength. Conditions under which this curing is carried out may affect qualities of material. Normally a damp atmosphere being desirable. Alright, now we go further. Now, principal methods which are used for stabilizations are mix in place, traveling plant, stationary plant. Mix in place, traveling plant, stationary plant. Mix in place method. Mix in place method. Construction. In this context, construction, a train of machines run over soil. A train of machines run over soil to be processed. Rippers, cultivators or rotary tillers are first used to break up soil, while plow or sacrifiers ensure that soil is loosened to a uniform specified depth. Rotary tillers. Rotary tillers. Rotary tillers pulverize soils as well. Water is then mixed to soil from a sprayer to bring it to suitable moisture content. Cement is then added either by hand or by means of a bulk spreader. After that, rotary tiller or a special type of soil mixer is again passed over soil. Mixing of soil with cement may be done either then you can say totally pillars ऐसा व्यवहार we add water and we have to spread cement. Now the dark much condition of this that mixed soil from state to bring it to suitable moisture content, and cement is then added either by hand or by means of bulk spreader. After that, rotary filler or special type of soil mixture is again passed to the soil. Mixing of soil with cement may be done either in dry condition or in wet condition. It is to be done in dry conditions. Water is added after mixing. After this, compaction. If it's been done in dry condition, then water is added after mixing. Come on, meaning now after that rotary tiller special type of soil mix is again passed over rock soil. Mixing of soil with cement may be done either by dry condition or wet condition. If within dry condition, water is added after mixing. After this, compaction of soil is done by rollers. Advantage of this method is follows: plant is simple, cheap, and can be easily transported. Number of machines required can be adjusted to size of job. Now it's traveling plant method in this. This was traveling plant method, then stationary plant method, then continuous mixer and batch plant. So we go through small this page. If you have time, see traveling plant method. Same working method is adopted as discussed above up to polarization of soil. And after that, soil and cement are lifted by bucket elevators and discharged into hub. Material then enters a pod mill through an adjustable apron gate. Edit. Material then enters a pod mill through an adjustable apron gate and water is added mixed into soil. Mixture is then discharged onto highway and spread with grader. Barber green mixture is mostly used for purpose. This may claims to following advantages: accurate and proportioning of added water, Accurate proportioning of added water, uniform mixing is achieved, needs less mixing time, depth of treatment can be controlled, highest output is obtained for, for a given expenditure and workers, but it requires high initial cost and work may suffer as suffer as a breakthrough takes effect. So what says in the beginning is same working as they did up to pulverization of soil. After that, soil and cement are lifted by bucket, elevator, and discharged to the upper. Material then enters a pug mill. Alright, so it says that material then enters a pug mill through an adjustable apron gate and water is added and mixed oil. Mixture is then discharged onto highway and spread with a grader. Farm grade mixture is mostly used for this purpose. This method claims following advantages: accurate proportioning of added water, uniform mixing is achieved, needs less mixing time, depth of treatment can be controlled, and highest output is obtained for a given expenditure and labor, but requires high initial cost. Then we go to stationary plant method. A stationary plant method, that you can say. There are two main types of stationary mixing plants: continuous mixers and batch mixers. In continuous mixers, principle of continuous mixer is similar to that of traveling mixer. Elevating loader supplies material to hopper with a mixing gate. Whence a belt conveyor discharges it to terminal. Right. तो आगे बात करने जा रहा है। So, continuous mixer, principle of continuous mixer is similar to that of traveling mixer. Elevating load and supplies matter to hopper with measuring gate, where a belt conveyor discharges to pug mill, where water may be mixed into soil. Mixed materials then discharged into trucks and sent to site. Batch mixer. On small jobs, this type mixer is used. Process identical to that used mixing cement concrete. Sometimes concrete mixers tinting from types are also used for this purpose. Advantage of stationary plant mixer use: accurate proportioning of mixture, thorough mixing is attained. Concrete mixers can be also used. There is no additional haulage. Soil has to be taken from furrow pit. Lime stabilization. Let's just give a brief of lime and then I'll close this, okay? I know we have got 5-10 minutes more on the subject. So maybe 5 minutes, 10 minutes a day. Lime stabilization. Soil generally contains sand. Silt and clay fractions. Sand, silt and clay fractions. Depending upon the nature of weathering, clay mineral present may be Montmorillonite. It's kind of German, but Montmorillonite, very dangerous. Montmorillonite, illite and kaolinite, or a combination of all these clay minerals. These minerals carry a negative charge on surface and to a large extent responsible for imparting plasticity to soil sample. Such type of soils have been successfully stabilized by lime decreasing plasticity of soil. Generally, use of lime is restricted to warm or moderate climate, where lime stabilized soils break up under freezing and thawing. Lime brings change in plasticity properties of soil. It decreases soil density and increases soil strength. It decreases soil density and increases soil strength. Lime acts with soil in three ways. So how? First of reaction is change of water film. Around clay minerals. Second process by which lime changes its soil is that of coagulation or flocculation of soil particles. Third process through which lime affects soil is reaction of lime with soil. Ingredients to form new chemicals. Two main ingredients of soil which react with lime are alumina and silica. Long-term reaction with two main ingredients of soil which reacts with lime are alumina and silica. A long-term reaction with strengthens soil lime mixture and is also known as pozzolanic action, due to which lime shall react with soil depends on quantity of lime. Now we go too far down. This is a long-term reaction. This is two main ingredients soil which react with lime and alumina silica. This is a long-term reaction which strengthens the soil lime mixture. So soil lime mixture, and it's also known as pozzolanic action. Degree at which lime react with soil depends on quantity of lime, soil type, and rate of curing of soil lime mixture. One most important properties of limes that changes soil's plasticity appreciably. Lime increases both liquid and plastic limits. I can't increase liquid limit. Lime increases both liquid and plastic limits for soils having a plasticity index of less than 15, which in turn increases plasticity index. However, in case of more plastic soils, lime decreases liquid limit and increases plastic limit, which in turn reduces plasticity index. Generally, lime is used from 5 to 10% by weight of cement construction works. Combination of lime and cement. Combination of lime and cement. I have to close it now. It's late now. I had to close this. Sorry. Just the combination of lime and cement. In this method of stabilization action of lime is utilized to start with reduced plastic nature of heavy clays. Additions of cement would bring about quick strength. Thus, basic reactions involved in this type of stabilization are base exchange, hydration, and pozzolanic action. Base exchange, hydration, and pozzolanic actions. Principles involved in producing a strong mix are same as those outlined under cement and lime stabilization. For a given amount of lime added to makes strength goes on increasing until an optimum amount of lime is I think well, we'll talk later. They say I'll talk later, no problem at all. No use of hurry because subject is like this. But it's interesting that we are moving on soil management, soil organization, which is lacking in the spirit of engineers. Maybe they raise it themselves. So no, I can't say, but one thing is certain. Again and again, engineer has to consider, without any hesitation, that foundation is incomplete if you do not understand soil. If you depend upon others to understand, if you depend on laboratory expert who is not an engineer, a scientist, certainly they are not engineering professionals. They should be. They are science professionals, BSc, MSc of soil. They may understand chemistry of soil, they may understand response of soil, but they may not understand engineering of soil. Engineering is required. That's my understanding of soil based on my experience. That because of engineering experience, you read soil, you treat soil with different aspect, different angle, different class. Only class of number one material is soil, which you reject. We never care of that. I've not seen any book in which soil is given so importance in engineering material. Engineering material you won't find soil in place. It should be given first place, but it's not there. Unfortunately, it's misunderstanding, misappropriation of engineering technology, but without this, nothing happens. It's very, very, very important. Well, it's up to all mature people, senior people, veterans who are having high qualifications, high degrees, that what they understand is up to them. I can't comment on that. But as a small engineer, too small engineer, consider yourself too small engineer, don't consider topping. Because small is beautiful, small is difficult, remember. Big is very easy, small is very difficult. And if you understand so small, and you have hunger to learn, you have a thirst to drink. If you are small, if you have a very big degree, then you will always keep in mind that which will never come out of your mind. It should come out of your mind. Whatever education you have, that is for your benefit, but it should not occupy your mind. You should develop your mind. Your hands should change. Your hands should use those, but no, it's not happening. Therefore, forget and try to learn. With practice, not simply learning, with practice. And don't confine to one specialization and field. Intercoordination is more important than specialization. If you cannot don't depend on softwares all the time. There are softwares, everything. There's business, they can produce software for anything. But for you, every software doesn't work. Okay, designs, okay, fine, I understand. But you cannot think, there is no thinking software. Your mind is thinking software. You use that. That's more important than something else. And I can understand your problems or you face in field. That's very, very important. Those problems are important. I understand that view. Everybody, is not that free to speak due to whatever reasons. But when you are on project, considerable project where items are important, engineering is important, coordination is important, and quality is important, technology is important. There you have to use your knowledge, learn the knowledge, not simply university knowledge, knowledge with experience, knowledge with attainment. That attainment is unlimited. That attainment is known by your actions, is known by your performance, known by your delivery, not by your certificates. Whatever certificate I have. For example, I am having, say, 1P certificate or IP certificate. It doesn't mean I am qualified to them. Okay, I got it, finished. I appeared in examination, I appeared in interview, and I qualified. It doesn't prove that I am competent everywhere. So everybody has some field, but I have to prove it again and again, again and again, every time, every project, every opportunity requires your confirmation of performance and your capacity, whether it continues to be built upon again and again, again and again. It's not simply that I got something and stop that. No, don't stop. I am referring this book which is 40, 50 years old. No problem. Old is gold. What's the matter? Something is there. Maybe I'll update. I'll take another book. What's the problem? That they go through that. At that time, I qualified from just getting through the examination. Now it's practice. It's real work. You have to understand 100%. That time maybe 50%. 60%. You have to understand 100%. And not only 100%, you have to analyze that, research on that, and add your contribution onto that. That's required. Very importantly, with this, I would say, I've taken appreciable time to take for this. I like to close this talk today, where I'm going through phase of soil, and purpose is that I want to confer on reports, soil investigation reports. So I thought before that I have to share with you people my little knowledge of soil, so that it won't be difficult to explain to you about those practical reports from site, which are of course very, very important for engineers. Those are descriptive reports, of course, but we have to understand those reports. As such reports are hundreds in their fields. Means you are go to site, you go to some project, you'll find those kinds of reports, and it's very important. Anyway, so thank you very much for your time. I close this now, and it's okay, fine. Thanks so much again. Thanks again here also. Thank you very much.